Very good evening and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. How are you guys? Let me know that sound quality, picture quality, everything is fine. Yes, please. Very good evening. How are you, Raghuram and Satya Sri? So please tell me that sound quality, picture quality, everything is fine. And today it is a very important session on what analog, and that is one of the most important subject for electronics, electrical and what instrumentation branch, and important as well as what interesting subject, right? And complete revision of important topics, right? So I think all are ready for this session, everyone. Okay guys, today's topic, Raghuram, today we will discuss what very important topics. Just I will inform you about that, those topics. Okay, don't worry. Then ओके कितने स्टूडेंट्स हैं यहाँ जिन्होंने प्लीज ज्वाइन द सेशन, शेयर द लिंक ऑफ दिस सेशन सो दैट स्टूडेंट विल ज्वाइन. यस, प्लीज शेयर द लिंक ऑफ दिस सेशन in your group. Okay, so this is a GATE 2023 electrical, electronics and instrumentation, that is the Maha marathon class for analog, that is the part 1 and that is the Bahubali part 1. Yes, remember here we are going to get the idea about two important topics, right? Complete revision in 4 hours. Okay, then stay tuned with me. First of all, this is my introduction. Myself Sanjay Rathi. I am having around 21 plus years of teaching experience, and during this I have mentored more than 1 lakh students. Okay, and I have qualified and selected for engineering services exam that is conducted by UPSC. These are my ranks: AIR 16 in ESE 2005 and AIR 21 in ESE 2008. Okay, guys. Subhankar, very good evening. Abdul, how are you? And साथ में हमारे हैं कृष्णा स्वामी, कृष्णा वेणी. Okay, L435 मनोज कुमार, how are you? तो चंद्रशेखर भी हैं, हेमंत. Okay, then this is a Maha marathon. Already we have started from 3rd January. Now digital over network, right? Control is running and what? Analog. Okay guys, then this is mega workshop by Abhinav Negi sir, MTech from IIT Delhi, 11 plus years of teaching experience. Now this is the 7 success mantras from a beginner to a topper in GATE 2024. It is a golden opportunity for new students. Live on 15th Jan 12:30 PM. Please note this time and date. Join this session. And that is another opportunity for new students. Take a step towards success in GATE. Get up to 90% scholarship. लेकिन इसके लिए आपको scholarship test देना होगा. तो that is register yourself on our official website or on our app. That is the date. Please note the date on 8th Jan at 12 PM. Right? That you are going to get the 90% scholarship on preparation program. Okay guys, you can join now. Right? Sir, yesterday's PDF. Oh, about network or about digital? Right. Now we are going to cover two important topics here. First topic is what? Complete MOSFET, that is important for electrical students, electronics student, because I am going to cover what? Analog part. And then we will discuss complete operational amplifier, right? Complete operational amplifier. So please ask your friends to join the session now. Yes, everyone. Okay. I think then the first topic is what? MOSFET, that is the field effect transistor, right? Then normally FET is divided into 2 parts. First one is what? Metal oxide semiconductor field effect transistor, and the second one is what? JFET. But remember in GATE exam that JFET, junction field effect transistor, is not in syllabus. So no need to worry about this topic. No need to prepare this topic. If you are preparing for engineering services exam, that is just after GATE exam, then yes, that is important for what? Engineering services exam. So we will arrange extra session for that after a GATE exam, that is the junction field effect transistor. Okay, now MOSFET, second topic is what? MOSFET, that is metal oxide semiconductor field effect transistor. Here we are having the two types of MOSFET. One is what? E MOSFET, and second one is what? D MOSFET. Enhancement MOSFET and depletion type MOSFET. Out of these two topics, E MOSFET and D MOSFET, depletion type MOSFET is what we are getting very one or two questions on depletion type MOSFET, but E MOSFET, that is enhancement MOSFET, is very important one, right? And we will discuss here biasing of the MOSFET, what about the important formula, characteristics, and how to solve the question. As well as I will give you the idea about what CMOS, that is complementary MOSFET, okay, PMOS plus NMOS, right? So normally E MOSFET is again divided into N channel or P channel. D MOSFET is also divided into what? N channel and P channel. So that is the classification of the MOSFET. Okay guys, then I think up to this point clear, just simple. So don't focus on this topic, please leave it and simply focus on this topic, that is what? MOSFET. Then simple MOSFETs are divided into two types, P MOSFET and what? N MOSFET. Now, right, first of all, everyone in a diagram you have to understand whether it is a PMOS or what? NMOS. If this type of symbol is given, 1, 2, 3, 4 terminal, this is called body terminal or substrate terminal, this is the source, that is the drain, this is the gate, then it is a symbol for what? P MOSFET. There may be a question on match the following and so on. This is a very basic question, and that is what? N channel MOSFET. This is the drain, this is the source, that is the gate, and this is. And my dear students, this is the CMOS. We are connecting the P MOSFET and N MOSFET, and that is called what? CMOS. For digital, again the CMOS is important in logic family. For electronics student, we are getting question from the C MOSFET in a digital. Okay, so here we will discuss some property of the CMOS. Then this is the P channel MOSFET and that is the N channel MOSFET. We will try to solve the question on both type of MOSFET and you will get the idea about the characteristics as well as formula for the currents. Okay guys, now first of all, in every MOSFET, very quick revision, we are going to revise all the concept here. This type of structure for P and E MOSFET. Here we are having the SiO2 layer, here we are having the metal, and this is the P type substrate, and that is the N positive, and that is the SiO2 layer. And here we are giving the gate voltage, here we are providing the drain voltage, here we are giving the source terminal. Normally the source terminal is connected to the body terminal and both are connected to what? Normally it is connected to ground. Here we are giving the positive voltage, that is the VGS is positive, great, it's positive. It should be positive. It should be greater than what? VT. And that is called threshold voltage for N channel MOSFET. It should be positive and it should be greater than what? VTN. If it is less than VTN, then the MOSFET will be in cutoff region. That is the, it means E MOSFET. There is no induced channel here, right? And this is called channel length L, right? Now it has width, that is called W. Then first of all, they will ask what is the value of the oxide capacitance? What is the value of the oxide capacitance? So quickly remember, we are calculating the oxide capacitance per unit length. So some students are making mistake. Always remember what is the formula for the capacitance? A epsilon by D. Epsilon A by D. Epsilon is what? Epsilon R, epsilon naught. But here A is not here, means it is the per unit area, and that's why the unit is what? Farad per meter square, and epsilon naught x is equal to 3.9 epsilon naught. 3.9 is the relative permittivity of SiO2. 3.9 into 8.85 into 10 raised to power minus 12 farad. No need to remember this one, extra burden, and that is the capacitance, overall capacitance. If in any numerical, if the capacitance is asked and the unit is given in farad, always multiply this with what? Area. So that is the precaution. So this is about the capacitance. First formula, first important formula, right? Then second one, In a triode region, there are three regions. One is called what? Cutoff region. Already I have given when the VGS is less than VT, that will be in cutoff. But if the VGS is greater than VT, but VDS is less than VGS minus VT, that is written here. Right? VGS minus VT. Then, if the VDS is less than VGS minus VT, then it is called, it is in triode region. So remember this formula, triode region directly. This is the formula in a triode region. Mu n COX, normally it is called K and S. Mu n COX, already I have given you the formula for that. W by L, it is called aspect ratio. VGS minus VT, that is the threshold voltage, into VDS minus half of VDS square. That is the in a triode region. Right. That this, what these characteristics? Here we are in triode region. And here we are in saturation. If you have any doubt, then you can ask. From this point to this point, this is called triode region and that is called saturation region, and this point is called VGS minus VT, and that is the value of VDS exactly at the boundary of triode and saturation. But when the VDS is very, very small in this region, very, very small, this is almost linear, straight line, it will follow the Ohm's law, but condition is VDS should be very, very small in this region. Otherwise, this is the bending of the curve, and now after that it will enter into what? Saturation. So suppose in any numerical, if it is asked, what is the condition for linear ohmic region? Linear ohmic region, remember, if the word is used linear amplifier, then remember it will be in saturation region. Linear amplifier means it will be in saturation. But if it is asked linear ohmic region, then it is in triode region, and when the VDS is very, very small. It is a special case of, yes. And here it is used as what? Well said, VVR. Right? Voltage variable resistor. So simply neglect this term. Directly, remember, electrical student, especially electrical students, directly formula based question in a GATE exam in electrical branch, directly formula based question. In last year, similar type of question, so please 2 marks, 1 marks, simple formula based. So formula based means in a linear ohmic region, when the VDS is small, VDS square will be very, very small. Neglect this and you will get the formula. So that is the formula, this one. When VDS is very small, that is written here, where the K and S is mu and COX, W by L, VGS minus VT into VDS. When I am doing the VDS upon ID, you will get the RDS in linear ohmic region. This is the RDS. This is the condition RDS, or that is the formula for RDS. So directly revise this formula, K and 1 by K and S, W by L, VOV. Okay, I think that is clear to you. Okay then. Once now this is clear to you. Second one in a triode region, sometimes they will ask what? GM. GM means change in ID because of change in VGS. Change in ID because of change in VGS when VDS kept constant. VDS kept constant. So my dear friend, in that case, simply differentiate the equation with respect to what? VGS. Use this formula and differentiate it. Means simply you have to differentiate this formula with keeping the VDS is equal to what? Constant. When I am differentiating this formula, it will become dID by dVGS is equal to mu n COX, that is the common, W by L, it is also common. Inside the bracket, VDS is a constant. So what is the differentiation of VGS? 1. And what is the differentiation of VT? 0, because it is a constant. So it will become VDS only. And what about the half of VDS square? It will become 0 because it is a constant. So that is the formula. That is the formula. Constant value of VDS. You have to put the value, constant value. Okay, that is called. Sometimes they will add GD. Sometimes they will add GD in a linear ohmic region. So that is nothing but the change in current because of change in what? VDS. When VGS kept constant. VGS kept constant. Number of times, that is the question. Okay. So they will give you the VGS, value of VGS. Simply differentiate this equation, this current equation with respect to what? VDS. When I am differentiating with respect to VDS, you will get the formula, and then with the help of that formula you can find what? GD. Yes, are you able to differentiate that formula with respect to VGS? With respect to VDS, drain to source voltage, that is called GD. So they will ask GM in linear ohmic region, GD in linear ohmic region. Okay, so these are the important formula. Okay, so differentiate it and you will get the formula. Now next one. So this is important. This is important. Differentiate it, and then this formula is very, very important. And this formula of resistor. Electrical student, directly they will ask find the resistor in linear ohmic region. Directly use this formula and you will get the answer. What is the VOV here? VOV is called overdrive voltage. Overdrive voltage means VGS minus VT. VGS between gate and source minus what? Threshold voltage VT. Okay. Then next one. Next question. Next. So ये है quick revision for that region. Now in saturation region. In saturation region, exactly at the boundary of triode and saturation, exactly at the boundary, what is the value of the VD set? And that is called VGS minus VT. Exactly at the boundary. Or otherwise in saturation region, always remember VDS is greater than VGS minus VT. Exactly at boundary it is equal, otherwise it is greater than. And this formula is half of K and S W by L VGS minus VT the whole square. This is the formula. K and S, you know, mu and Cux. But remember, sometimes they will give the formula ID is equal to K times of VGS minus VT the square. Okay, no problem. Where K is nothing but half of K and S W by L. Each and everything is constant, and that's why it is replaced by what? K. So it will become VGS minus VT the whole square. Directly you can use. Last year, same question on that. Same question. You have to find the ratio. You have to find the threshold voltage. In every numerical, you have to keep this value constant. It will become very, very easy. Now, tell me, what about this? Linear or non-linear? It is proportional to what? Square. Square of that. And that's why the characteristics is what? Non-linear. Characteristics is non-linear characteristics. This type of characteristics. That is the VGS. That is the ID. And this type of curve. Up to threshold voltage, current is 0, then square. And that is the what? VT. When the VGS is less than or equal to VT, the current will be 0. After that, it will follow this curve, non-linear curve. Right. But when we are keeping the signal, very small signal, very small signal, then we can make it what? Linear. Means we are varying the signal, when we are applying the signal, we are varying the signal in between these two values. Very small variation in VGS, and we are keeping the VDS at this point. This is called biasing. This is called biasing. VGSQ. For example, VGSQ is 2 volt or 3 volt or 5 volt. So we are keeping this VGSQ is here, that it is a 2 volt constant value. And here we are having the DC current IDQ. But when we are applying the AC signal, for example, VGS is only 2 volt. Then when we are giving the VGS 0.2 sine omega t, remember 0.2 sine omega t is very less as compared to 2 volt. So what is the total voltage, applied voltage? 2 plus 0.2 sine omega t. Maximum value is 2.2, minimum value is 1.8. So this is the 2.2 and this is the 1.8. For this reason, it will maintain the linearity. So I am just highlighting the curve. This is the linear reason. For this path, for this reason, the slope will remain constant. The slope at this point, we are calculating the slope. We are calculating the GM at this point, that is called transconductance. The slope will remain same from this point to this point. And what is the meaning of the slope? Change in ID because of change in VGS. When VDS kept constant. Change in ID because of change in VGS. And remember, ID is what? Independent of VDS. Independent of VDS. So that is the saturation region. I think this is clear to you, everyone. This point is clear. How? So they will ask in this this time in MSQ they will ask any type of question. It may ask theoretical question और भाई देखो सब आ गए हो. If you are enjoying the session, please mark your attendance by simply liking the session. Please like the session if you are enjoying, because it is a part 1. Now tomorrow we are going to take what? Part 2. It is a 4-hour class, right? And continuously I will give you the basic idea and each and everything about the MOSFET, as well as after that we will cover what? Operational amplifier, each and everything, all the applications of the operational amplifier. Okay, तो सब के सब एक बार जरा लाइक कर दीजिएगा सेशन को. ओके, अब देखिए जरा, दिस इज द GM. तो when we are differentiating this formula, we can get the formula for what? GM. We are getting the GM is equal to K and S W by L VGS minus VT. Okay, then try to understand. If that is the formula, we have the different types of formula for GM. Why I am giving a theory here? Because so that we will be able to solve the question. Suppose that is one formula, but from this formula you can find the VGS minus VT. So you can replace the VGS minus VT in terms of ID half of K and S W by L. So that will be the, we are going to get the another formula for GM. If suppose the K and S W by L is not given in the question, but K and S W by L you can replace, you can find the K and S W by L from this formula. Try to understand. What is the K and S W by L from this formula? K and S W by L will become 2ID upon VGS minus VT the whole square. 2ID upon VGS minus VT the whole square. Now put this value here. When I am putting this value here, it will VGS minus VT is cancel out, and what is the formula for the GM? The formula for the GM will become 2ID upon VGS minus VT, and that is what we got, 2ID upon VOV. This is called overdrive voltage. So electrical students, there was one question. Yes, right, Chandrasekhar. हाँ, अभी अगर सर भी आएंगे, that MN sir will also come, right? Okay then. So my dear students, what is this? In particular numerical, if particular numerical they are giving, for example, this type of numerical, they are giving ID on this much, VGS on this much. If this is given, use this ID on and VGS on here, and you will get that definitely they will provide you the threshold voltage. So you can find the GM. Or otherwise, if ID on it is given, ID on is equal to full constant half of K and S W by L. Put here VGS on minus VT the whole square. In this way you can get the value of what? Constant. Value of constant. Once you will get the value of the constant, you can find the GM, or you can find what? ID for different values of VGS. So that is the method. So sometimes they will provide you this type of values. Okay, so directly use this formula, VGS on, ID on, or this is the formula, ID on, you can find the value of K, that is what? Constant. Okay, so this is the, here K, remember, always remember, half of K and S W by L. Any doubt up to this point? Any doubt? Any doubt, then please ask me. That is the question about the MOSFET theory. Then try to solve this question, everyone. First of all, 1 minute, this one, channel length modulation. In every numerical they will ask, ignore the channel length modulation, right? So what is the channel length modulation? Or in some numericals you have to consider the channel length modulation. So in electrical branch normally they are saying that neglect the channel length modulation, but for electronics student, instrumentation students, they will ask consider the channel length modulation. If suppose I am considering the channel length modulation. Channel length modulation means in a saturation region there is a variation in the current because of VDS. Otherwise we are saying that there is no effect of VDS, it is independent of VDS, but actually that VDS will affect the ID in saturation region, and that's why this curve is somewhat elevated. When somewhat elevated means we have to change the formula. Half of K and S W by L VGS minus VT the whole square. This is multiplied with what? 1 plus lambda VDS. 1 plus lambda VDS. Due to channel length modulation. It is called channel length modulation parameter. This is called process technology parameter or parameter related to channel length modulation. This lambda is given by 1 by VA, where VA is the early voltage. VA is the early voltage and it is proportional to 1 by length selected for the channel. More will be the length, less will be the value of lambda. Is it clear? So that is inversely proportional to length and that is the value, and this is the formula. Always remember, they will provide you the value of VA or they will provide you the value of what? Lambda. The unit of lambda is per volt or VA is volt. 1 by VA, from 1 by VA we can find what? Lambda, and then use this formula if you want to consider the channel length modulation. So that is given by the early, and that's why it is called early effect. Okay, I think this formula is also clear. Now try to solve this question fast. Which type of question? First type of question in GATE exam, direct straight question, right? For example, 1 minute here, this in the design the circuit that transistor operates at ID is equal to 0.4 milliampere, VD is equal to 0.5 volt, NMOS, N channel MOSFET has VT is equal to 0.7 volt, mu and COX 100 microampere per volt square. Remember the unit of K and S is 100 microampere per volt square, or it is sometimes it is given as milliampere per volt square. This is the mu and COX. Length of the channel W is given. Neglect the channel length modulation. So normally if it is given, then lambda is equal to what? 0. Lambda is 0. If the design the circuit means in an option they will give you two options. What is the value of the RD? It may be MSQ. What is the value of the RS? Right? And what about the MOSFET? Whether it is in saturation, MOSFET is in saturation or MOSFET is in a triode region. Tell me. So this is the MSQ, multiple select question. You have to find the value of RD, check the answer. You have to find the value of RS, check the answer. Whether it is in saturation or triode, out of these two, one answer will be correct. Tell me, what about the MOSFET? So this is the first type of question. So very basic question. Always remember W is greater than L. That's why the aspect ratio W by L, that is what? 32 divided by 1, it will become 32. Unit micrometer cancel, that's why it is a 32. Then this ID is given in milliampere, 0.4 milliampere. Therefore, you can also convert the mu and COX. Mu and COX is equal to 0.1. 100 microampere is converted into milliampere. Milliampere per volt square. Now, what is the next information? VD is given as 0.5. This VD is given as 0.5 volt. VG is connected to ground. VG is connected to ground. There is a current ID 4 milliampere and there will be the current ID that is given. In any numerical, if the current is given, so tell me, this is in cutoff. If suppose it is in cutoff, then what about the current? How the current will flow? If the current is given, it is a non-zero value, means it is not in cutoff. Not in cutoff. Not in cutoff. Why? Because ID is not 0. And therefore, VGS is definitely greater than what? VT. VGS is definitely greater than VT. Okay, not in cutoff, it is greater than VT. Second thing, if we want to solve this question, it is very simple to check this answer RD, because the voltage at this point is given, VDD is given, ID is given. Very simple thing, you can find the RD. What is the RD then? RD will become VDD minus VD divided by what? ID. Very simple. 2.5 minus 0.5 divided by ID 0.4 it is given. So du divided by 0.4, that is nothing but 20 by 4. 20 by 4 is 5 kilo ohm. So if the A option is given as 5 kilo ohm, okay, this is the right one. It is MSQ. Then second, to calculate the RS, first of all we have to decide whether it is in triode region or what, in a saturation region, because otherwise we have to find the value of the VGS here. VGS, we have to find the value. To understand the concept whether it is in a triode region or saturation region, always check, new students always check what is the value of VD. In particular numerical it is given as 0.5 volt, okay. Then check the value of VG. VG is connected to ground. VG is connected to ground. This is the VG is connected to ground, and VD is what? 0.5 volt. This is given in numerical. Already you have find the value, that is the 5 kilo ohm. And this is the 0.4 milliampere. Okay. Now this same current will flow through this. Remember, IG is always 0 because it is a insulated gate field effect transistor. This is the SiO2 layer. And that because of this IG will be 0, but this time gate is connected to what? Ground. Directly we can say VD is greater than what? VG. Once it is greater with respect to ground, we can say VDS with respect to S is greater than what? VGS. Directly. This is the with respect to ground, this is with respect to source. Now definitely we can say VDS is greater than what? VGS minus VT. Any doubt? Because it is not in cutoff and IG is 0 always, yes. No, not in cutoff, and that's why we are checking that VDS. What about the VDS? VDS is greater than VGS minus VT. Once it is verified, it means it is in saturation. It is in saturation. Now, if once we are getting the saturation, we have to find the value of the VGS. Why we are finding the value of VGS? To find the value of RS. Remember, this is the VGS. Write down the KVL. Write down the KVL here in this loop. When I am writing the KVL in this loop, this is 0 is equal to VGS, 0 is equal to VGS plus ID into RS. ID into RS minus 2.5. Minus 2.5 volt it is given here, 2.5 volt. So what is the value of the RS? RS will become 2.5 minus VGS upon what? ID. This is the formula for RS. In this question, ID it is given, 2.5 it is given, we have to find the VGS. To find the VGS, we have to use the formula for the saturation region. This is the formula. What is the formula? IDS is equal to half of K and S, that is mu and Cux, W by L, VGS minus VT the whole square. What is the current given? 0.4 milliampere. Half. What is this? 0.1. Already we have calculated, this is the 0.1. Mu and Cux is nothing but K and S. 0.1 milliampere per volt. Put the value here, 0.1. W by L 32. Aspect ratio. You have to calculate the VGS. It is given as 0.7 volt square. Now it is very easy. It will become 4. This is 16. This is 4 divided by 16. 1 by 4. Root of 1 by 4. That is equal to VGS minus 0.7. Root over 1 by 4 is equal to plus minus 1 by 2 is equal to VGS minus 0.7. You are going to get the two values of VGS. One is 0.7 minus 0.5, 0.2, and one is 0.7 plus 0.5, that is 1.2. Which is correct? Which one is correct? Viswanathan Murli, why it is in saturation? Yes, I will explain. Okay, no problem. VGS is equal to 1.2, that is correct. Why it is correct? Everyone tell me. Why we are rejecting the second one? Why we are rejecting the second one? Because it is less than what? Threshold voltage. If it is less than threshold voltage, my dear student, it will be in cutoff, but it is not in cutoff, and that's why we have to neglect this value. It should be greater than what? Threshold. So once you will get the VGS, directly you can find the value of RS. 2.5 minus 1.2 divided by what? 0.4. This will become 1.3 divided by 0.4 or 13 divided by 0.4. You can find now the value 3.25 kilo ohm. Yes. Now, so that is the answer for this particular question. Check my calculation. Yes. Then they will give you the second option, 3. Suppose this is given 3.25 kilo ohm. So this is also correct. This is correct. This is wrong. So what is the answer? A, B, C. A, B, C. A, B, C. Now, what is the problem? Sir, why saturation region? Acha. Why saturation? Remember one thing. What is the condition for the saturation? This VD should be VDS. Okay. Always check this. I am again giving you the explanation how we can judge. Right. Always check. We have to satisfy this condition. VDS should be greater than or equal to VGS minus VT for saturation. Okay. First of all, check the VD. If the VD is 0.5, okay, so VD is equal to 0.5. And what is the VG? Terminal voltage is 0. How 0? It is connected to ground. What about the VS? We are not having the value of the VS. It may be any value. Vx, for example, Vs is Vs or Vx. No problem. So what is the VDS? VDS will become VD minus Vs. So it will become 0.5 minus Vx. And what is the VGS will become? VGS means VG minus Vs. So it will become 0 minus Vx. So tell me which one is higher. This is 0.5 minus Vx is greater than 0 minus Vx. So we can say VDS is greater than what? VGS. Okay. Now I am subtracting 0.7. So what is the VGS minus VT? It will become 0 minus Vx minus what? 0.7 volt. So definitely if this is greater than that, 100% sure that VDS is greater than what? This value. Or otherwise, if you want verification, you can put the value Vx is equal to what? 0.1 or 0.2. You can put. Right? You can find the value here. Okay. Now it is clear. That is the value. So in this way we can verify it. Verify it. Okay. देखिए ये है first type of question. Now second, what is this? I am giving you the another theory. This is what? This is called what? Simply find the unknown values of the resistors. This is one type of questions. We are discussing very systematically. We are discussing variety of the questions. Right? Which type of questions they may ask. So second is biasing. Biasing means we have to keep the transistor or MOSFET in what? In triode region or in what? Saturation region with the help of DC signal. That is called biasing. So creating the circuit to establish the desired DC voltage and currents for the operation of the amplifier. The 4 common ways of the biasing. One by one we will discuss. Biasing by the fixing the VGS. Biasing by fixing the VG and connecting a resistance in the source. Biasing using a drain to gate feedback resistor, and biasing using a constant current source. Constant current source. There are 4 types of diagram. Right? In saturation, yes, VGS should be greater than what? Yes, VT. And VDS is greater than VGS. Yes. Now, watch this type of biasing. If this is given in the question, RD is given, VSS minus VSS, always remember here the positive value is connected, here the negative value is connected, because in case of MOSFET, enhancement MOSFET, always remember VGS should be positive and it should be greater than what? VT. In case of N MOSFET, and that's why here we are giving the negative value, here we are giving the positive value. So if this type of question is given, remember the current through the RG is 0. Directly you can find the VGS here. So VGS will become VG minus VS. and that is nothing but VGG minus minus VSS. Always remember, minus of minus VSS, because it is a negative value. So it will become VGG plus what? VSS, and that is the value of VGS. In a particular numerical, you can directly find the value. First. Second, once you will find the value of the VGS, you can use the formula for the current, right? That is what ID. That is what ID, half of K and dash W by L VGS minus VT the whole square. Yes, just opposite. I will give the formula for the P MOSFET also. Second thing, if the AC or DC, both the signal is given, always remember, make it what? Short circuit. For large signal analysis, make the DC 0. If it is given as VGG, 2 volt something else, so directly you can find the VGS. So VGS will become VGG. VGS will become VGG, and once you will get the VGG, you can use the formula. Right. In case of P MOSFET, they will give you this type of diagram. Suppose this is given, for example. Then here they will provide you the VSS positive value. This is the arrow. This is the source terminal. Current will enter into the source, leave the drain. Here we are getting the output. This RD is given. Okay. And in that case, we have to calculate VSG. So when we are calculating the VSG, it should be greater than what? Mod of VTP. Remember, for P channel, threshold voltage is negative, but with the help of mod, we are making it what? Positive. So always remember, if the VTN is equal to 1 volt, then VTP is equal to what? Minus 1 volt. But with the help of mod, we are making it positive, and we are changing the subscript. VGS should be negative, but what about the VSG? VSG should be positive. VSG should be positive, greater than 0 or greater than threshold voltage. So that is the P MOSFET. To P MOSFET, change the formula. Just simply change the, very good evening Nirmal, how are you? Change the formula. Formula means very simple formula. Always remember, change the subscript. VSG should be greater than mod of VTP. VSD, if it is less than VSG minus mod of VTP. Triode. In a triode region, write down the formula. ID is equal to Kp dash W by L VSG minus mod of VTP into VSD, change the subscript, minus half of VSD square. We are simply, this all are positive, na? VSG should be positive, it should be positive, this should be positive, and because of that mod it will become positive, and that is the formula. Where the Kp dash, always remember, mu P COX. Similarly, when VSD is greater than or equal to VSG minus mod of VTP, that is called saturation. So what is the formula in the saturation? ID is equal to half of Kp dash W by L VSG minus VTP mod the whole square, and that is the formula. So some student will ask, why you are giving the formula, sir? Why you are giving the formula? Right, I am saying that in electrical branch, direct formula based question, what is the formula in saturation region, what is the formula in triode region. In electronics branch, again the formula in saturation region, what is the formula in what? Triode region. So right, I think now it is clear. Hemant, in case of P MOSFET, this is the formula. This is very, very important one. This is with condition. Condition I have mentioned there. Okay, and that is the formula in saturation region. Right, diagram like this. You have to calculate the VSG, you have to calculate the VSD. Plus, minus. This is the VSD. Right, and this is the drain terminal voltage. and that is gate terminal voltage, right, and that is given source terminal voltage, and we are getting the output from this. Okay, next one. So I think this formula is clear. We are just change the subscript and put the mod in threshold voltage. So this is about the MOSFET. So different types of question, right? So we are giving different types of biasing. That this is the biasing. Try to understand in this case. Yes. In PMOS again the IG is 0. In PMOS again the IG is 0 because of insulated gate field effect transistor. IG current is 0. Now this current is, no doubt I am writing the ID, but actually it is flowing from what? Source to drain. Source to drain. Actually we are writing ID, but it is from source to drain. Then another type of biasing, like for example, simply we are connecting the RS here. RS here. Now tell me, if I am simply connecting the RS or I am connecting this with respect to ground, I am not connecting anything here. देखो लेकिन क्या लिखा है? Biasing by fixing the VG and connecting a resistance in the source. If suppose I am connecting any battery here, okay, then I can calculate the VGS. So VGS will become VGG minus drop across this RS. VGS will become VGG minus ID into what? RS. Remember, directly you can use this formula. VGG minus ID into RS. This will give you the value of VGS. And this value should be greater than what? VT. VTN. If it is less than VTN, then definitely it will be in cutoff. Okay. Now, I am just giving you a very conceptual question. If suppose I am removing this battery. If I am removing this battery, I am connecting simple RS only. And this is connected toward ground. Nothing is connected here. This is the ID. And here I am connecting VDD. If only RS is connected in a diagram, then it is called what? Self-biased circuit. What is the name of this circuit? Self-biased. In case of MOSFET, self-biased. If suppose I am giving only RS, this is called self-biased. But when I am going to calculate the VGS by applying the KVL, you will get the VGS is equal to what? Minus ID into RS. Minus ID into RS. Or for in case of eMOSFET, if the VGS is negative, the circuit will be in what? Cutoff. Circuit will be in cutoff. And that is the question. That is the question, objective question. Why self-biased technique is not used in case of eMOSFET? Because it will provide the negative value of the VGS. And because of this negative value, what will happen? Because of this negative value, it will be in cutoff. It will be in cutoff. Okay, 1 minute. But if there is any doubt, then please inform me. Okay, right. Then next one, next type of biasing. I am just giving you how to solve the question. For example, this is given. This is given, okay. So that is called what? Potential divider biasing. Potential divider. RG1, RG2 is given. RD and RS is given. Then it is simply what? Potential divider. Because single battery is required here. Only single battery VDD is connected here. So just like a BJT, solve by using what? Potential divider. What is the current inside that? IG is always 0. So no need to calculate the RTH, only calculate what? VTH. So what is the VTH at this terminal? This is nothing but VGS or VG. This is given by RG2 upon RG1 plus RG2 into what? VDD. Once you will get the VTH, draw the circuit. Right. No need to find the RTH. Otherwise, RTH is nothing but RG1 parallel with what? RG2. RG1 parallel with RT2 is RTH, but no need to find. Why? Because the current is 0. What is the drop across the RTH? 0. So this will become VTH, and that is nothing but VGG. And now you can find the VGS. What is the current? ID. What is the current? ID. And this is the RS. Then the VGS will become VTH minus ID into what? RS directly. Here third type of question, voltage division rule directly. So agar aap, if suppose we are focusing on what 5 type of question, then definitely that question will be from this 5 types. Okay. So this is the first one. Cell biasing is not applicable in case of what? If this battery is given, okay, it should be positive value. If the battery is not given, it is called cell bias, and that cell bias is not used in case of E-MOSFET. Second thing, that is the formula. Already it is given that by fixing the value of the VGS, and then we are applying the battery as well as what RS, that is called potential divider or voltage divider biasing. Another type of biasing is what? This is, we are putting the negative value here. Remember, no doubt RS is connected, but here we are giving the negative value of VSS. Yes, it is okay. How it is okay? It is okay because when I am writing the KVL in this loop, what is the current through the RG? 0 is equal to VGS. This is the plus minus VGS plus ID into RS. Already we have solved one question. Minus VSS. So what is the value of the VGS? VSS minus ID into what? RS, and that is greater than what? VTN for N channel MOSFET. If it is positive value, yes. If we are not able to connect the positive voltage here, we can connect what? Negative voltage here. That is correct. That is correct one. RS plus battery, negative value. If here we are connecting battery, then it should be positive battery. If here we are connecting the battery, it should be negative battery, so that the VGS should be positive, and that in this way we can solve the numericals. In every case, before finding the current, we have to find what? VGS, that is called drain to gate to source voltage for saturation reason. I think this is also clear. This is another type of diagram. So 4 types of diagram: potential divider or with negative. Already we have solved this question. Already we have find the value 3.25 kilo ohm. This is the 5 kilo ohm. This was given. This is given VD 5 volt. Already we have solved this question. Okay. Okay, then next one. This type of biasing. If this is given, then tell me, Murli and other students, please tell me what about the transistor? It is in which region? In this case, no need to verify the region. Why? Once the drain, this is the drain terminal, is connected to what? Gate terminal through a resistor. But what will be the current in this branch? 0. And the value of this resistance is very, very high, that is in the range of what? Mega ohm normally. But what will be the current? 0. And that's why the drain voltage is exactly equal to what? Gate voltage. Both are equal because there is no drop, just like act as what? Short circuit. When the VD is equal to VG, we can say VDS is equal to what? VGS. Then we can say VDS is greater than what? VGS minus VT directly. It is 2 volt, it is 2 volt, it is 2 volt, it is 2 volt. One, it is when I am subtracting, it will remain 2 volt, it will less than 2 volt. So definitely it is greater than that. If it is greater than that, directly we can say it is in which region? Saturation region. So number of times questions on this diagram. Number of times. Or remember, if RS is not given, or if RS is given, again, no problem. VDS is equal to what? VGS. This is important. VDS is equal to what? VGS. So suppose in sometimes it is output is obtained, output is required, V0. V0 is nothing but VDS, and VDS is nothing but VGS. Directly you can solve this question. So this is called biasing using a drain to gate feedback resistor. Biasing using the drain to gate feedback resistor. This is the feedback from this point to this point. Okay. Hope so. That diagram is also clear. This diagram is also clear. राइट तो भाई थक गए क्या आप लोग? बस रिस्पॉन्स देते रहिए. इफ यू आर एंजॉइंग द सेशन एंड लाइक द सेशन. ओके गाइज, नेक्स्ट वन. नेक्स्ट Yeah, straightforward question on all this diagram, but now we will solve some questions. Last type of biasing is what it is called, biasing using a constant current source. We will discuss that current mirror circuit. We will discuss what current mirror circuit also. Then here we are simply giving a current source, constant current source. In a particular numerical, if the current source is given, for example 1 milliampere or 10 milliampere, it is given here. So that is the value of what ID. That is the value of what ID. Use the formula, you can get the value of VGS from this point to this point. Right? They will mention what about that, it is in whether it is in saturation or cutoff or saturation or triode region. Value of ID is given. Write down. No need to write the KVL and so on. Simply with the help of that formula, IDS is equal to half of K and S W by L VGS minus VT the whole square. You can find the value of VGS. So this is a very simple current source is shown here, but actually it is a current mirror circuit. This is the current mirror circuit by using MOSFET. So we will solve 2 to 3 questions on current division, current mirror circuit. This is a very important diagram. So this is another type of biasing in case of MOSFET. Already I have given all type of diagram. Now in exam you have to solve all this. Okay, this is the biasing and now I am going to solve some numericals for you. Look, first of all try to solve this numerical. What is the answer? This is which type of biasing? Everyone tell me, which type of biasing? That is a question in exam. Which type of biasing? 8 mega ohm RG1, 7 mega ohm R2. What is the value of this? Very high, mega ohm. RD, RS it is given. In the circuit shown in the figure, the MOSFET is operating in the saturation zone. It is a voltage division biasing. Voltage division and with the RS. The characteristics of the MOSFET is given by, half is given, VGS minus V the whole square. So what about the remaining constant? K and S W by L. It will become 1. Finished. Because only half is given, so K and S W by L is equal to what? 1. Characteristics of the MOSFET is given by where VGS is in volt. If the VS is 5 volt, then the value of RS in kilo ohm. If this time this VS is given as 5 volt. 5 volt it is given. Okay, no problem. You have to find the RS. Already it is given. That is the characteristics. If this is the characteristics is given, means in which region? Tell me everyone. In which region? Already characteristics is given. If the characteristics is given, means it is a square of that. It is a threshold voltage, means what? It is in saturation region. So already it is mentioned in a saturation region. So directly in saturation region, first of all make the potential divider and write down the KVL. Finished. Or you have to find the value of that value. Okay. So what is the formula? Potential divider here. What is the potential divider? Once it is divided, potential divider means what is the voltage across the 7 mega ohm? 7 divided by 8 plus 7 into what? 15. That is the value of VTH. It will become 7 volt. You are going to get the 7 volt here. Once you will get the 7 volt, connect this. No need to calculate the RTH. This is connected to ground. This is given as 5 volt. Now already we have calculated. This is the VTS 7 volt. So what is the value of VGS? This is nothing, the value of the VG. What is the value of the VGS? VGS will become VG minus VS. 7 minus 5, that is what? 2 volt. That is 2 volt. Once it is known that is the 2 volt is the VGS. So what is the current here? ID. RD is not given, VDD is not given, not required. What will be the current here? ID. Same current. Once you will get the value of ID, VS is known, you can find the value of RS. Because VS is equal to ID into RS. VGS is known. With the help of this formula, ID is equal to 1 by 2. What is the value of the VGS? 2 minus 1 the whole square. So it is what? 1 by 2. That is 0.5 milliampere. 0.5 milliampere is the value of ID. Okay. Now you have the value of the ID. This is the value is 5 volt. So what is the Vs is equal to? Vs is nothing but Id into Rs. So what is the Rs is equal to Vs upon Id. 5 upon 0.5. Remember it is in milliampere, and that's why it will become 50 by 5, 10 kilo ohm. 10 kilo ohm is the answer for this question. 10 kilo ohm. Why you are giving the 25, Hemant? How? Akanksha, Vasisht, your answer is correct. Yes, 10 kilo ohm. Tarun, Tanvi, 10 kilo ohm. So tell me, my dear student, is it a tough question or a very easy question? Very, very simple. But if it is for new students, definitely it will be tough, because if you have no idea how to solve, then it will become very tough. The simple potential divider, remember Ig will be 0, the current through this branch will be 0. Therefore, no need to calculate the RTH. No need to calculate the RTH. We are wasting our time. This is the value of the Vg. This is the value of Vs. You can find the Vgs. Use this formula to find the current. Already it is given, that is in saturation. Very simple question. So हाँ हेमंत, silly mistake. We are doing normally silly mistakes. हमारी कश्ती थी डूबी वहाँ जहाँ पानी कम था. So normally we are making mistake in easy question. Please try to maintain accuracy. Now this type of question, another type of question, very simple. For the transistor M1 in the circuit shown in the figure, mu n COX is 100 microampere per volt square, WL is 10, mu n is the mobility of the electron, COX is the oxide capacitance. My dear, in exam hall these all are the normal. So please read all these things very fast, not needed here general things, but read this. WL is given as 10, this is the given as okay. The channel length modulation coefficient is ignored, lambda is 0, again this is not required. Please read these all these points very fast. Okay, in exam they will give you this value. हाँ मैं just इसके बाद MOSFET amplifier ही करवा रहा हूँ. If the gate to source voltage VGS is 1 volt, to keep the transistor at the edge of the saturation, then the threshold voltage of the transistor. In this question only the threshold voltage is required. If the gate to source voltage is only 1 volt, right? Then what is the value of the saturation voltage? And any other thing is given here. M1 shown in the mu n COX is given, W by L is given, okay, VGS is given at the edge of the saturation. Okay, now try to understand. Now you can find the value of what? VGS, already it is given. What is the value of the VGS is given? 1 volt. At the edge of the saturation means what is the formula for the current? IDS is equal to half of K and S W by L VGS minus VT the whole square. So we have to find the VT. We are not having the idea about the ID. We have half K and S W by L. VGS is known but IDS is not known. At the edge of the saturation, what is the value of VD? This is nothing but value of what? VDS, because the S is connected to ground. So at the edge of the saturation, VDS is equal to what? VGS minus VT. VDS is equal to what? VGS minus VT. That is the value. So we have the two equations, right? VDS, and what is the value of the VDS? 3. That is the VDS is equal to 3. That is the VDD minus ID into what? RD. Minus ID into what? RD. So we have the value 3. No idea about the ID, but it is the 20 kilo ohm. 20 kilo ohm. That current will be in milliampere. Now we have the value of VGS minus VT. This is nothing but value of VGS minus VT. Put this IDS, right? Or you can find the value of ID in terms of that and you can solve. You are going to get the quadratic equation, solve it. But once again in a quadratic equation, we are getting what? We are getting two solutions. But one solution will satisfy the condition that the MOSFET is in saturation, or one solution will not satisfy. So please remove that solution and take that solution which will satisfy the saturation. Or once if it is ID, if we are getting the positive value or negative value, then choose what? Positive value. Before question RD is 18 kilo ohm means, sir, if any basic question regarding the analog circuit comes in the gate, can we crack it if only following your? Yes, why not? Why not, my dear? If they are giving the very basic question, 70 to 80% are the basic questions, and right, on based on what previous concept, around 20% questions are new questions. Okay, but what about the basics, my dear? We are covering what? All type of questions here. Okay, so I think that is clear. So I am not going to solve this. You can solve this. We are having the two equations. What is asked here? VGS, the transistor at the edge of the saturation, and the threshold voltage of the transistor rounded off to 1 decimal places. Once you will find the value of ID, from this you can find the value of VDS, you can find the value of VGS minus VT. Use this. Two unknown, two equations. Two unknown, two equations. Right. Okay. Okay then. Okay, that is the 0.5. If yes, then okay. Okay, guys. Yes, it should be less than what? 1 volt. Yes, I think answer is what? 0.5 volt. So normally in MOSFET we are having the two equations from the given condition. From these two equations we are having the two unknowns, and we have to find that two unknowns, ID or VGS, ID or what? VT. If the VGS is given, then we have to find the ID or VT. So in this question we have to find the ID and VT. Next one, this is the 0.5. Okay, now tell me, what about the MOSFET? Directly we can say it is in what? Saturation, because it is connected here. And that's why it is in. Directly we can say saturation, and here the VDS is equal to what? VGS. Directly we can say the VDS is equal to what? VGS. This is the one type of biasing. This is called drain gate biasing, feedback. Find the value of required R and the DC voltage VD. Both we have to find the value of R as well as DC value of VD. That the NMOS has ID 80 microampere, VT is given, mu and CUX is given, L is given, W is given. Neglect the channel length modulation. Very easy question. Directly, once you will have the idea, directly write down the formula. ID is equal to half of mu n COX W by L VGS minus VT the whole square. DC voltage VDS is nothing but VGS, that is nothing but VD, because the source is connected to ground. So directly from the formula, ID is given 80 microampere. Half of mu n COX is given 200 microampere. W by L aspect ratio is given 4 divided by 0.8. Micrometer cancel. Okay, and what is given? VT is given. Then VGS is nothing but what? VD. 0.6 it is given, whole square. From this you can find the value of VD. From this you can find the value of only one unknown, VD. 0.6 it is given, this is given, that is given. You have to use the formula microampere, you can find the value of VD. Once you know the value of VD, you have the value of ID. What is the R? R will become 3, this is the 3 minus VD upon what? Current. Current is given in the question, so you can find the R. Easy question, easy. This is easy one. So normally in MOSFET, yes, they will ask this type of question. Now I want to enter into what? Amplifier by using what? MOSFET. So yes, you are getting the VD 1 volt. Yes, well, that you can verify it. I am giving you the method how to solve this question. One known equation, that they will repeat the concept. They are not going to give the same data in coming exam. They will change the data. Okay, calculation is your part, but that is the method. Okay. Then another type is one minute, my dear students. This is the yes. Now amplifier. Amplifier means Yes, this time they will ask very important questions on what MOSFET, amplifier by using what MOSFET. Last year again 1 or 2 questions. For again in electrical branch, again different types of question. You have to get the command over what small signal model, and the small signal model is very easy for what MOSFET. This is the small signal model. We are having the voltage G VGS, GM VGS. This is the GM VGS, and that is what R0, right? Or sometimes R0 is given as what RD, drain resistance, and that is what effect of early effect, that is given by RD, or drain resistance R0 is given by VA by IDQ. Or what is the VA? 1 by lambda into IDQ. Sometimes in a particular numerical, lambda is given, IDQ is given, you can find the value of R0 with the help of this formula. If suppose R0 is not given and nothing mentioned about what lambda or VA, then simply there is no early effect. No early effect means lambda 0. Neglect early effect. Neglect early effect, or channel length modulation means lambda 0. Lambda 0 means what is the RD or R0? Infinite. Infinite. Make it what? Open circuit. Right. Vishal Grover. A number of students are from what? South India. That's why. Okay. Okay, I will try. This is the VGS, this is the GM VGS, that is the R0. To neglect the early effect, lambda is equal to 0, RD is equal to R0 is equal to what? Infinite. It is a small signal model, GM. Already I have given you the formula of the transconductance. In every numerical you have to find the GM. What is the GM? K and S, W by L. This is the DC biasing. From DC biasing, find the value of VGS minus VT the whole square. That is the K and S, W by L, VGS minus VT the whole square. You have to use this formula. Okay. Find the GM and so on. Now, just try to understand this diagram. For example, I am just giving you the general diagram. Within 10 minutes, you will get the idea about all the configuration. Let this is the RS, this is the RD, this is the VDD. Here I am connecting the VI. If suppose I am getting the output from this terminal, then it is called common source. If I am getting the output from this terminal, then it is called common drain. So if the output is V01, this is called common source. Because the source terminal is common, we are giving the input to the gate terminal, we are getting the output from the drain terminal. If I am getting the output from drain, then it will become common output from source, then it will become common drain. We are getting the output for source, we are giving input to the gate, and that's why it has become common drain. So with one, are you ready for 10 minutes? With one derivation, you will get each and everything. You will get the idea about what common drain as well as common source, and what is the effect of RD and what is the effect of RS, each and everything. Very simple method I am going to explain you. If suppose I am making the RS is equal to 0, it will become what? V01, means it is a common drain, it is a common source. If I am making the RD is equal to 0, again we are taking the V02, again it is a common drain, right? Common drain is also called what? Source follower. Source follower. Very simple derivation within 10 minutes. Now, first of all, write the diagram. Then, draw the diagram. Okay. After that, always remember during AC analysis, we are assuming that this MOSFET, it is in saturation region. That's why it is work like what? Amplifier. It is in saturation region and work like what? Amplifier. Okay. Then draw the small signal model. Draw the small signal model. What is the small signal model for this? A small signal model means simply GM VGS. This is RD. Okay, and remember this is the drain terminal, this is the source terminal, and that is the gate terminal. Bas, always draw like this, GM VGS RD. Okay, then this voltage is called VGS. from this point to this point. Okay, this is the small signal model. Now watch this diagram. For AC analysis, always make all the DCs equal to 0. If there is any capacitor, then this capacitor will act as what? Short circuit. All the capacitor will act as short circuit during AC analysis. Now from source to ground, RS is connected. Connect RS here. And now make proper ground here. This is the ground. Okay. Then second thing, from gate to ground, VI is connected. So where is the gate? This is the gate. Connect the VI. VI means applied voltage. It may be VS, VI or VS. Applied voltage is connected here, VI. Okay. Now when the VDD is 0, from drain to ground, drain, this is again a ground because we are making the VDD is equal to 0. So drain to ground, RD is connected. Drain to ground, RD is connected. Okay. Here from drain to ground, we are getting the output voltage V01. This is the V01. And across the RS, we are taking output voltage V02. Simple. This is the small signal model. Easy, guys. Any doubt? Any doubt here? No. Once you will get the idea about the small signal model, that is the small signal model. Okay. Then KVL, KCL, only very simple thing, KCL and KVL. So I am going to apply this KVL and KCL. That is the diagram. If I am considering the V01, then it will become the common source. I am considering the V02, it will become the common drain. Right. Now, watch this. The PDF will be available on my Telegram channel. So everyone please join my Telegram channel. That is Electronics by Sanjay Rathi. This all the written material will be available on my Telegram channel. So please share the link of this session, right, so that student will join. 1 minute. Just after this session, I will upload the PDF. So no need to write, just simply focus on the board. Okay. And if you want to solve some numericals, then yes, you can solve with the help of virtual calculator. Okay. Now, this is the model. So try to understand. First of all, what is given here? VGS. But what is connected here? VS. So what is the KCL here? KCL means what is the current? Let always remember this is the drain current ID inside this model. Now what is the current in this branch? GMVGS. So what will be the current here? Current will become ID minus GMVGS. Any doubt here? ID minus GMVGS. This is the ID minus GMVGS. Now at this point we have to add this current and this current to GMVGS cancel out. What is the current here? Again ID. Again ID. Now here, because we have to solve the question in terms of what? VGS, but get the VGS in terms of VS. To get the VGS in terms of VS, we are writing the KVL here in this loop. Write down the KVL. When I am writing the KVL here, it will become VS, that is the applied voltage. This is the minus VS plus VGS plus ID into RS. ID into RS is equal to 0. And then we can say what is the VGS is equal to VS minus ID into RS. This is the equation. Very simple. Then directly write down the KVL. In exam you can solve within what? 1 minute. Draw the model, draw the KVL, and that is the basic thing. Now write down the KVL in this highlighted portion. So what is the KVL? Right, go through the current. So it will become ID into RD. This is the ID into RD plus small RD into ID minus GMVGS plus ID into RS. That is the KVL. So it will become ID into capital RD plus ID minus GMVGS into what? Small RD plus ID into RS is equal to what? 0. ID into RS is equal to what? 0. That is the second equation. Finished. Now from these two equations you can find the ID. So what is the ID? First of all, replace the VGS by VS minus ID into RS. So you can write RD, take common, small RD, take common, RS you can take common, minus this VGS is replaced by, it is the GMRD minus GM into RD. This VD is replaced by VS minus ID into RS is equal to what? 0. Okay. Now from this you can find ID is equal to RD plus small rd plus RS plus what? Minus. Right? This is the RS. Minus minus it will become plus, plus GM RD into what? RS. GM RD into what? RS is equal to, here you are going to get the GM small RD into what? VS. GM small RD into what? VS at the right side. Now from this you are going to get the current. What is the formula for the current? That is the most important one. GM RD into what? VS upon RD plus RD plus RS 1 plus GM RD, and that is the formula for ID. So they may ask what is the formula for the ID. So directly you can draw the model and simply you can find the value of this RD ID. Once you will get the ID, what is the V01? Tell me. What is the V01? V01 is actually minus ID into RD. Why negative? Because here the current is ID. So what is the current here? Negative ID. Minus ID. And that's why V01 will become, when I am talking about the common source with RS, because their RS resistance is given here, RS. This is called unbypassed RS because that capacitor is not connected here to RS. The common source with RS, output will become ID into minus ID into what? RD. Directly you are going to get the answer minus GM small RD VS into capital RD upon capital RD plus small RD plus RS into 1 plus GM RD. My dear students, from this you can solve any type of MSQ. Any type of MSQ means, tell me, if I am going to increase the RS, what about the output voltage? If I am going to increase the RS, what about the output voltage? So what is the gain here? The gain is given by, this is called mid-band gain. It is with 180 degree phase shift RD plus small RD plus RS plus 1 plus GM RD. That is the formula. So we are getting the 180 degree phase shift, or in denominator there is a RS, not only RS, it is multiplied with the 1 plus GM RD, and this is a very very high value, very high value, and because that is the effect of RS. When we are increasing the value of RS, in case of common source, the output voltage will, the gain will decrease. There is a 180 degree phase shift, and from this we are getting the approximated answer also. Sometimes within seconds we can solve. If RS into 1 plus GM RD, this value is very greater than RD plus RD. RD plus RD and GM RD. Normally the GM RD is very greater than 1. What will happen? RD plus RD negligible, 1 negligible, GM RD cancel out, GM small RD cancel out. You will get approximated answer for this circuit. AVS is equal to minus RD by RS. So in 90% cases, electrical branch, electronics branch, instrumentation branch, in 90% cases that will be the answer. That will be the answer. So why we are doing the derivation? Tell me, what about this result? Krishna Murari Singh, very good evening. This result, the magnitude is overestimated. Why overestimated? Because we are neglecting this. Because we are neglecting RD in denominator, we are neglecting 1 from the denominator, and that's why overall value will increase, but with 180-degree phase shift. So what is the approximated answer for this? Minus RD by RS, highly stable, and that's why it will provide you what? Negative feedback. Because of negative feedback, gain is highly stable. It is independent of transistor parameter. Which are the transistor parameter? GM, small RD. It is independent of small GM and small RD. That's why it is independent of transistor parameter. I think that concept is clear, and that is the role of what? RS. That is the role of RS. But suppose in any numerical, if RS is not given, then it will become common source. So no need to draw the diagram and so on. If it is output, it is given only, RD is given, VDD is given, VS is given, RS is 0 here. No RS is given. Without RS, it is called common source, because we are taking the output from the drain. So in this numerical, when I am making the RS is equal to 0, what will be the result? Then the gain, directly we can say minus GM small rd capital RD upon small rd plus capital RD, and that is minus GM RD dash. What is the RD dash? RD dash is nothing but small rd parallel with capital RD. And directly you can solve this numerical directly without giving any model, or no need to draw any model. Directly you can give the answer for this particular numerical. Very simple. I think this is a very simple thing. 180-degree phase shift. Common source is analogous to common emitter. That's why we are getting 180-degree phase shift. So that is about what? Common source with the RS. Now if suppose you want to solve the common drain, then you have to take the output across the RS. So what is the output across the RS? V02. V02 is what? ID into what? RS. V02 is what? ID into what? RS. Yes, RD, RS. Yes, no, that is right, Chenwara. ID into what? RS. So what is the ID? Already I have calculated the ID. This is the ID. GM RDS upon RD plus RS GM RD. So directly I am going to write here. Yes. फिर common drain with drain resistance RD, So output will become ID into what? RS. From the diagram, ID into RS, V02. So what is the ID? That is the formula here. GM RD VS. GM RD VS upon into RS upon RD plus RD plus RS 1 plus GM RD. That is the formula. This is a very simple formula. So what is the gain? V02 by VS. This will become GM RD RS upon what? RD plus RS 1 plus GM RD. Without any negative sign, that's why the phase shift is what? 0. That's why the phase shift is 0. And remember one thing, if any numerical, if RD is not given, so you can neglect this RD. Otherwise, remember, it is in denominator. If the drain resistance increases, then gain decreases. Because this time MSQ, always remember this derivation will help you. Right? What is the role of the capital RD? If I am increasing the capital RD, in case of common drain, the gain will reduce. But if suppose the RD, it is not given, or if RS plus 1 plus GM RD is very greater than what? RD plus RD. Remember this result, because in numerator there is a word GMRDRS. Here it is a GMRDRS and then extra term, and that's why this gain is what, less than 1. It is already less than 1. It is not greater than 1. It is less than 1. Then in that case, if suppose I am neglecting this, this is a very large value, I am neglecting this, and again the GMRD is very greater than 1. GMRD is very greater than 1. So I am neglecting the 1. GMRD cancel, RS cancel. What is the gain? Exactly, you are going to get the plus 1. You are going to get the plus 1. Then output is exactly replica of the input, and we are taking output from what? Source, and that's why it is called source follower. That's why it is called source follower. I think complete derivation, each and everything about this diagram and so on, directly you can find this numerical, and this is the diagram. Hope so. Clear concept? AC analysis. No, we will solve different types of question, but this is a two important diagram, common drain and common source. Okay. Next, I am going to solve some questions. So this is all about the common drain and common source, small signal model, right? How to apply the small signal model. Now give me the answer for this particular question. How to calculate the small RD? If the early voltage is given, then you can calculate the small RD. If small RD is not given in the question, take it what? Infinite. Okay, give me the answer for this question, everyone. What is the answer for this question? Which one of the following gain equation is correct for a MOSFET common source amplifier? No doubt all are given positive. No doubt there will be 180-degree phase shift, but not given. Okay, which one is the best answer? Best answer is yes. So not given, no problem. Magnitude is given. GMRD. It is not a printing mistake. It is given in the exam. So best answer is what? GMRD. Small RD is also not given. So if the small, actually answer is what? Small RD parallel with the capital RD. But if the RD is not given, take it what? Infinite. Infinite parallel with RD is what? RD. Minus is not given, no problem. It is magnitude is given. GMRD. So this type of question, direct, straightforward. Then sometimes this type of question is given. In electronics branch, for already given, I have given the two derivation. That is important for electrical, electronics, instrumentation branch. But electronics student, remember, if this is given, this type of diagram is given, then in the circuit shown in the figure, the channel length modulation of all the transistor is non-zero. Non-zero means all MOSFET have R0 or RD. R0 or RD. Also, all the transistor operate in the saturation. Already it is given that all operate in the saturation region, right? All operate in the saturation region. Then also all the transistor operate in the saturation and have negligible body effect. Body effect is a part of EDC. So we have to neglect the body effect. The AC small signal voltage gain of the circuit is, what is the V0 by Vin? You have to find the small signal voltage gain. Now my dear friend, minus GM1, minus GM1, minus GM1, minus GM1 is given. Minus GM1 is given means it is a driver. It will drive the circuit. It is a main amplifier. This is a driver. What about this circuit? It is a load. Actually, it is a load. Right? Now, in that case, again, we have to apply the model. We have to use the same model, whether it is a P MOSFET or N MOSFET. This is a load, and this is what? Driver. But normally we are saying that here, sir, I am putting the load like this, RD. But this type of load, and this is called active load. What is this? This is called active load. MOSFET, this is the active load, and that answer is given R01, R03, and so on. This is the parallel connection. And we have to find, very simple, you have to draw the small signal model. You have the idea about that small signal model for all the three transistors. So what is when I am doing the AC analysis, always remember this all the DC sources will act as what? 0. This is 0, right? V in is connected here, V out is we are taking here. This is the DC voltage, that's why it will act as short circuit. So gate terminal is connected to ground. Here this is 0. So what about the gate terminal? What about the drain terminal? Connected to ground. Source and drain. Its source terminal is connected to ground. Source terminal is connected to ground. It is the drain terminal of first one. It is the gate terminal of first one. It is the source terminal of first one. Right. And that is the model. First of all, simply draw the circuit GM VGS1. GM1 VGS1, because it will become VGS1. Draw the model for this GM VGS1 and put here R01 parallel to that. Remember, this is the source terminal and source terminal is connected toward ground. Source terminal is connected to ground, and in a gate terminal, this is the gate terminal, we are connecting the VI. This is the gate of 1 and this is called VGS1. From this we can get what is the value of the VGS1. VGS1 will become VI, because this is ground, this is the VI, so it will become VI first. So we can replace the GM1 VGS1 by GM into VI. So you are giving the answer C, I will check this. Okay. Then second, draw the diagram for this. It is in this is what about the source. Above you can change the polarity here. GM VGS2. Now this is the source. This is the R02. Right. What about the gate terminal? Gate terminal is connected to the ground. This is connected to the ground. VG G2. New students, please try to understand this G2 is connected to ground. G3. And this is the VGS3. This is 3. Okay. And now its drain terminal VGS3. Its drain terminal is connected to D1. Where is the D1? This one. This is connected here. Okay then. Finally, what about this model? Again draw the one model here. GM3 here, GM2 here, VGS2 here, R02 here. This is the drain terminal and drain a source terminal. This is the source terminal and source is connected to the drain. Connect this, and we are taking the output from this V0. This is the output V0. Now this is the model, my dear friends. What about its drain terminal? Its drain terminal is connected to what? Ground. What about its source terminal? Its source terminal is connected to what? Ground. So you can connect like this. It is also connected to ground. Both are connected to ground. Now what about this one? This is the G3, this is the S3. So this is called VGS3. So if this is ground, so what is the value of the VGS3? 0. If the VGS3 is 0, my dear students, what about this source? This source, current source, will act as what? Open circuit, because this is G3 is connected to ground, S3 is connected to ground. Therefore VGS3 is equal to what? 0. Directly from this you can say VGS3 is equal to 0, and that's why this current source will act as what? Open circuit. Now what about the VGS2? VGS2, when I am saying that VGS2, try to understand this gate, this what? Gate is connected to ground. But what about this source? It is V0, and therefore VGS2 will become minus V0. VG minus VS2, it will become minus V0, and therefore this current source will become GM2 into what? Minus GM2 into V0. Right? Now that is all about this diagram. That is all about this diagram. Very simple. Now write down the KCL at this point. write down the KCL at this point, please. Then when I want to write the KCL at this point, everyone please focus on the diagram. What is the outgoing current? GM1 VGS1, and what is the VGS1? VI. So outgoing current GM1 VI plus KCL V0 upon R01, V0 upon R01 plus V0 minus 0 upon R02 plus V0 minus 0 upon R03 plus, what is this? It is incoming. So what is the outgoing in opposite direction? It is minus downward. So what is the plus? GM2 into V0. In upward direction it will become GM2 into V0 plus outgoing GM2 into what? V0. Anything else? R02, R03, it is over. Because it is 0, no need to consider it. And that is the VGS already I have solved. That is equal to what? 0. Now, you can take the V0 as a common. It will become 1 by R01 plus 1 by R02 plus 1 by R03 plus what? GM2. That is nothing but parallel combination of all the conductance. This is conductance, that is conductance, this is conductance, that is conductance. Conductance we are adding in parallel. This is the V0 is equal to what? Minus GM1 into VI. So what is the V0 by VI? You are going to get the answer for this question, minus. So, which answer is correct? Minus GM1, right? And that is the R01 parallel with R02. Which answer is correct? I think C, no? Yes. This is the C is the correct answer for this question. Okay guys, any doubt? Any doubt? What is this? 1 by R01, 1 by R02, 1 by R03 plus GM2. So you are saying that, sir, it is in denominator. Okay, no doubt, it is in the terms of what? Conductance. It is in the terms of conductance. You have to satisfy the unit. You have to satisfy the unit. Which one? GM1, VGS1? Oh, VGS1 is nothing but VI, na? What is the VGS1, Chinmay? What is the VGS1? Already I have given, na? VGS1 is nothing but VI. Already we have solved. Right. And that's why I am writing the GM into VI for GM1 into VI. Okay. So this formula is clear, everyone. That is nothing but parallel combination of R01, R02, R03 and what? GM2. GM3 we have to neglect because VGS is equal to 0. Now, my dear, in this formula, GM2 is not given. In this formula, GM3 is given. That's why that is not the answer. Right? So in this formula, again, you have to verify with this to, oh, I think two answers are same, but no. Yes, yes. These two answers are same. Okay, that is a printing mistake. Don't worry about that. But this is the C is the answer one. Okay. हाँ, वो printing mistake. There is a printing mistake. Both the answers are same. I take R02, R03, and this is the answer. So number of times this type of questions. Now this is all about what? MOSFET. Now I am going to start what? Operational amplifier. Ready guys? तो एक बार जरा यार फिर से शेयर कर लीजिए, लिंक शेयर कर लो और अब स्टार्ट करने वाले हैं ऑपरेशनल एम्पलीफायर. तो देखो ये दिस टाइप ऑफ क्वेश्चंस, सिंपली ड्रॉ द मॉडल, स्मॉल सिग्नल मॉडल, proper, get the value of VGS1, VGS2, VGS3. Once the VGS is 0, make this current source open circuit, remove this current source, simply focus on the remaining one. Focus on the remaining one. Draw the neat and clean diagram. Practice 4 or 5 questions, ultimately you will get the answer. You will get the short tricks also. Okay then. So now one more question on what? Current mirror circuit. Current mirror, because number of times that question on what? Current mirror circuit by using MOSFET. So what is the current mirror circuit by using the MOSFET? First of all, The circuit in which output current is forced to equal the input current is called a current mirror circuit. When the output current is forced to equal the input current, that is called current mirror circuit. So no doubt the MN sir will cover what? Current mirror by using the BJT, right? MN sir will cover the BJT. I am here to cover what? MOSFET and operational amplifier. So tomorrow at 4 to 8 p.m. please join that session. So what is the advantage of the current mirror circuit? Why we are using the current mirror circuit? It is very simplicity in the circuit design, easy to fabricate, very easy to fabricate in IC technology. Minimum number of component is required, low cost. That is what? Current mirror circuit. That's why it is preferable in IC fabrication. So why I am giving this theory? Here MSQ, multiple select question. Then this is the current mirror circuit. Always remember, this is a driver, right? Here I am giving one I reference. Always remember, one I reference is given here, or something register is given here. You have to calculate the current here. Now W by L, if this ratio are same, this ratio and this ratio is same, both are identical, then in that case I can say I2 is equal to what? I reference. Output current is the mirror image of the input current. It is independent of the load. If suppose I am connecting any type of load here, it may be inductor, it may be capacitor, it may be resistor, or it may be any type of circuit, the current will remain same. It is simply controlled by what? I reference. So I is equal to I reference, but condition applied, W by L of 2, and all the characteristics should be same. आपने GM3 VGS क्यों नहीं लिया? ओके आकांक्षा, GM3 VGS3 क्यों नहीं लिया? ओके GM3 VGS3 क्यों नहीं लिया? वो 1 मिनट रुकिए जरा, ना मैं बता रहा हूं जब तक करंट मिरर सर्किट बताते हैं. अरे वो VGS3 0 है ना. टेल मी what is the value of VGS3, Akanksha? VG is connected to ground because it is a DC voltage, that's why it is connected to ground. VS is connected to ground. So what is the value of the VGS3? 0. Once the VGS3 is 0, what about the current source? Is equal to 0. If the current source is 0, it will act as what? Open circuit. Remove this. That's why I am removing. Okay, DC, all the DC battery should be equal to what? 0. And that's why we are not considering. And that is the shortcut. That is the shortcut. Once it is GM3 is open circuit, but in answer there should be no GM3. So, but in one answer GM3 is given. It is, if it is GM3 is given, that B is not the choice. But we have to consider the GM2. Why? Because in that case is VGS is not 0. VGS is equal to what? Here the VGS2 is equal to minus V0. And that's why we have to consider it. So that we can neglect what? Second answer also. Which answer? Is this answer. So from these two we can choose, because both answer is given same. Otherwise, without solving, we can solve within 30 seconds. Without giving the diagram. Simply by calculating what? VGS1, VGS2 and VGS3. Okay. That is very easy. Or directly from this you can find. This is 0. Short circuit. This is 0. So what is the VG? 0. This is V0. And what is this V in? In model, VGS1, VGS2, VGS3 is required. Directly we can find. Okay. Now current mirror circuit, right? This is the current mirror circuit. If property, all the properties are same. Properties means what? K and S, W by L of 1 is equal to what? K and S, W by L of 2. All are equal. Then the voltage from this point to this point are same because they are connected in parallel. So VGS1 is equal to what? VGS2. Property same, voltage same, and that's why current will be remain same. But if suppose I am changing the aspect ratio, for example W by L is, we are varying the W by L, then in that case the current, if W by L2 is not equal to what? W by L1, then in that case the output current, this output current or ID2 will become, because it is directly proportional into what? I reference. That is the formula. That is the formula. If you want to get the 2 times, 3 times, 4 times, but by simply setting this ratio, you can get the 1 time, 2 times, 3 times, or 4 times. I think now you are ready to solve some questions. Always remember when this terminal, drain terminal, is connected to source, they will ask question, na? When the drain is connected to the gate, it is in saturation, and both the transistors should be in saturation. It should be also in what? Saturation. If both the transistors are in saturation, definitely if it is in saturation, then definitely it will be in saturation, because VGS is same, and the current in this direction and current here will remain same. So why we are connecting gate and drain? So that it will remain in what? Saturation. It is a driver. It will drive the circuit. It will drive the circuit. That will be the question. Okay then. So now in normal case, that is the question. Tell me what is the answer. In the circuit shown, V1 is 0. Where is the V1? This is the V1. This is the V1. 0. If it is the V1 is 0, this means this MOSFET is what? Off. Then 1 milliampere current source is given. W by L 3, W by L 5, W by L यहाँ पे 10 दिया हुआ है, W by L यहाँ पर 10 दिया हुआ है, यहाँ पर 5 दिया हुआ है, यहाँ पर 40 दिया हुआ है. W by L aspect ratio is 40. Yes, too high. So what is the current here? I out. That is asked. Now here we are also using what? P MOSFET. We are also using the P MOSFET. So remember, when P MOSFET is given, we are designing the current mirror circuit by P MOSFET. Actually, this is the source in case of P MOSFET. Okay, that is the diagram. In case of P MOSFET, this is connected here, and this branch will give the current, and that is the source. This is the drain. Here we are connecting the load, or again the drain is connected to gate, right? This is, here we are connecting the battery actually, VSS or VDD. This is the reference current. Here we are getting the I reference, and same current here we are getting I reference. Now what is the difference between this and that? In that case, first of all, the current will pass through the load and then it will enter into the MOSFET. So here the MOSFET act as what? Sink. Act as what? Sink. First of all, the current will pass through the MOSFET, pass through the load, and finally it will enter into this MOSFET, and that's why it acts as what? Sink, right? Here we are connecting the load. This MOSFET will give the current to the load, and therefore it will act as what? Source. So this type of concept is required in what? Digital logic family. Digital in logic family, fan out, fan in, this type of question. So this act as what? Sink, source, and previous one is act as what? Sink. First of all, current pass through the load, then through the MOSFET. So that may be the new question, because already it is given. It is given. So what is the current? Now, so there are two types of current mirror. This is by using the P MOSFET. This is by using the P MOSFET, and there is a one by using the N MOSFET. Watch this carefully. This is the diagram. I think it is visible to you, everyone. Okay then. Very simple. In the diagram directly, this is the current mirror circuit, 1 milliampere. The W by L is 2, W by L is 3. So what is the current through this? I naught. Let I am giving I naught. Let I am giving the name. This is the 2, this is the 1, this is 3, this is 4, 5, 6, and what? 7th. 7 total MOSFET. If it is 1 milliampere, so what is the I2? I2 will become W by L of this 3. What is the W by L of this? 2 into 1. That is the 3 by 2 milliampere. I2. Then what is the value of the V1? It is given in the question 0. Once it is 0, it is an N MOSFET, and that's why it is cut off. If it is in cutoff, what will be the current? 0. What is this current? 0. Because there is no VGS, and that's why this voltage will become 0. What is the value of the V2? V2 is given as VDD. V2 is given as VDD. That's why this MOSFET will be in saturation. Then the current, this I2, what is the path of this current? I2 is nothing but I7. This will flow like this. And what is the I7? That is nothing but I reference. That is I5. So what is the I5, I reference, I27? All the current will become. Because they all are connected in what? Series. All are connected in series, and that current will become 1.3 by 2 milliampere. 3 by 2 milliampere. Because these all are connected in series. That is the series path. Now, since the I reference to this is 3 by 2, and what is the W by L? 10, and what is the W by L? 40. So we can say I out by I reference is equal to I out by I reference is equal to this divided by this, 40 divided by 10. That is nothing but 4. What is the I out? 3 by 2 into 4, because I reference is 3 by 4. It will become 6 milliampere. 6 milliampere. So how many students are giving? Yes. ठीक है, Sibu and Niharika, everyone. So some students are highly worried about this type of diagram. Due, VDD, MOS, NMOS, short, sir. Why? VDD is not short circuited. VDD is given. VDD is what? If it is a short circuited, then means what? It will become it will off, and it will off means what? That is in cutoff, right? Part of the circuit is given, right? All the resistors and so on. That biasing is not given, Sibu. This V1 is given as 0, and that's why this is what? Off. This is given as VDD, and that's why it is on. Okay, guys. If it is 0, always remember the voltage at this point will be positive. When the voltage at this point is positive, so 0 minus positive is what? Negative voltage. When the VGS is negative, that will be in cutoff. And definitely, if the voltage at this point is at 3 volt, for example, I am giving 3 volt. The voltage at this point is at 5 volt. So 5 minus 3, what about this MOSFET? This MOSFET is in what saturation region? This MOSFET will be in saturation, or it is on. It will allow the current. It will allow the current. So always remember, some students were saying, sir, how we can say the VGS is equal to 0, because V1 is the VG. So what about this voltage? Definitely this voltage will be positive, because it is the VDS. VDS is greater than VGS minus VT. That's why it is in saturation. 0 minus something positive is what? Negative. That's why it is in cutoff. Or VDD means it is the highest voltage present in the battery. VDD means what? Always remember, highest voltage present in the battery. For example, it is 5 volt. If saying that it is a 5 volt, so definitely at each and every node the voltage will be less than 5 volt. That's why at this node the voltage will be less than 5 volt. Here it is a 5 volt is given. So what about this voltage? Definitely it will be less than the 5 volt, because energy can neither be created nor be destroyed. It will be never greater than what? 5 volt. That was one question. In one question we are getting two answers. One is what? 7, one is 3. One answer 3 is correct, 7 is not correct. Why? Because the supply voltage is only 6 volt. So how is it possible to get the node voltage or particular at particular point more than the supply voltage? Practically not possible. So that is the case. Any doubt? Easy question. तो ये है current mirror circuit. By number of times, number of questions on current mirror circuit. Right. I am giving you one homework. I think you have already solved this question. Otherwise, solve this question and give me the answer in comments box. Very simple question on current mirror. I am giving you the hint. 1 milliampere. Same 1 milliampere will flow through this. Same 1 milliampere will flow through this. Why? Because current gate terminal current is 0. You have to find the V out. The voltage at this point is 6 volt. Definitely the V out will be less than the 6 volt. You have to find VGS4. Once you will get the VGA, but always remember these two are connected in series. When these two are connected in series, therefore VGS4 and VGS3 are equal. To find the VGS3, find the VGS4. 6 minus VGS4 will give you the V out. Okay. So this is the case. all are identical, W by L is same, everything is same, right? So 1 milliampere, same 1 milliampere will flow through this. So what is the drop across the 4 kilo ohm? 1 into 4, 4 volt. So what is the voltage at 2 volt? 6 minus 4, 2 volt. So what is the value of the VGS 3? 2 volt. If this is 2 volt, these two are connected in series, therefore the current will be same, and that's why it is also 2 volt. If it is 2 volt, 6 minus 2, what is the answer? 4 volt. No need to homework, directly solved. Okay, easy. So new students, third year students, remember that don't worry about this type of questions, right? See that directly we can say this is the answer. So ask your junior to join the session. This type of question in GATE exam, so definitely new students can get the good result. एक ही रीजन है उनका, बिंदास बनाते जाओ क्वेश्चन, बिना डरे बनाओ, कई बार क्या होता है रिजल्ट अच्छा आ जाता है। और मैराथन जो नए हैं, खासकर जो नए स्टूडेंट है जो पहली बार दे रहे हैं, वो तो अटेंड कीजिए, हो सकता है एज इट इज क्वेश्चन आ जाए, पूरा कंप्लीट रिवीजन हो रहा है। नाउ आई एम गोइंग टू स्टार्ट व्हाट? ऑपरेशनल एम्पलीफायर। आर यू रेडी गाइज? आर यू रेडी और डू यू वांट 3 minutes ब्रेक? यस, टेल मी। लेकिन यार ये ब्रेक के बाद सब गायब नहीं हो जाना भाई। यस, तो जस्ट 3 minutes ब्रेक, राइट? तो 3 to 5 minutes। यार टाइमर मुझे नहीं पता टाइमर कहां से आता है, लेकिन चलिए जो भी है। ये देखिए 6:05 हो गए और आप मुझे यहां पर दिखाई दीजिएगा आफ्टर जस्ट 3 minutes। ओके देन, ब्रेक है, अब आ जाइएगा बस सबके सब। Hello guys, again welcome back. Please join the session. Now we have to cover what operational amplifier. Please ask your friend to join the session. Please ask your friend to join the session now. Okay. Then operational amplifier. Okay. So operational amplifier, then what will be the first question? We are back. Okay, then please join the session, everyone. Okay, guys. Operational amplifier, that is again a very important topic, and for electrical students, electronics, instrumentation branch, last year number of questions on this topic. Again, every year there will be the question on this topic, and that is the quick revision of this topic. Okay, ready guys? So what about the MOSFET? You got some command over the MOSFET, right? I try to cover almost all important topics. It is not possible to cover each and everything, but okay. Already we have done some questions on amplifiers, questions on current mirror circuit, questions on biasing. But what about the characteristics and other thing? That is the part of what electronic devices and circuit. In EDC, I will cover CV characteristics. That is the MOSFET. CV characteristics. So electronics student, please wait for the class of EDC. That is electronic devices and circuit, where I will cover what MOS capacitor, right? And MN sir will cover different topics, semiconductor physics, MOSFET, right? So wait for the class of EDC. Then I am going to start with the operational amplifier. To like the session, एक बार जरा लिंक शेयर कर दीजिए. Ask your friends to join the session now. For PDF, join my Telegram channel, that is Electronics by Sanjay Rathi. Already I have sent the link. Please download the app, that is Telegram, and then join that so that you will get the PDF just after this class. Okay then. So what about the properties? So definitely for some students, that sometimes they will ask what is the ideal condition and what is the practical condition. So voltage gain, as you know, operational amplifier is basically a voltage amplifier. For any voltage amplifier, what about the ideal voltage gain? Infinite, practically 10 to the power 6. Input resistance, it should be infinite, practically 10 to the power 6 or 1 mega ohm. Output resistance, it should be as low as possible. Gain bandwidth product, that is called figure of merit of any amplifier. Ideally it should be infinite, or practically it is 10 to the power 6, it is constant. Operational amplifier is a multi-stage amplifier. Give me the reason why it is a multi-stage amplifier, everyone, in comments box. Why multi-stage amplifier, operational amplifier? What is the basic purpose of operational amplifier? Why it is multi-stage? MSQ, they will ask in MSQ, multiple select question. Bandwidth, ideally infinite, practically 10 to the power 6 when we are giving the negative feedback. Common mode rejection ratio. Actually, it is a differential amplifier. It is a direct coupled amplifier. It is a differential amplifier. And we are calculating CMRR, common mode rejection ratio. And another important property is what? Slew rate. That is called maximum rate of change of output voltage. Maximum rate of change of output voltage. That is called slew rate, that is infinity, and practically it is 80 volt per microsecond. Volt per microsecond is the unit of this. So Payas Kumari, how are you? Navneet, to reduce the bandwidth. Okay, so differential amplifier cascaded with the high gain amplifier. My dear, you are not giving the correct reason. No doubt, one is saying that, Hemant is saying that sir gain increases, yes. Another one is saying that the bandwidth decreases. My dear, we want the bandwidth should be as high as possible. So what is the basic purpose? Gain bandwidth product increases. To gain bandwidth product increases, that will be the question. Remember one thing, always remember, they will ask why operational amplifier is a multi-stage amplifier. Number of stages, right? Remember, in first stage we are using the differential amplifier. It may be by using MOSFET or it may be by using the BJT. So that is the differential amplifier, like this. Here one emitter is connected here. This is the minus V, this is called V set, minus V set, and here we are connecting VCC. This is the differential amplifier. You can change the polarity of this two in this direction. Here we are giving the VS1 or VS2, or here we are giving VS1. That is the differential amplifier, first stage. Second stage, we are using the common emitter or other amplifier to increase the gain. And what is the purpose? Finally, the purpose is what? To increase the gain bandwidth product. Gain bandwidth product increases due to multi-staging. Due to multi-staging, bandwidth decreases. Due to multi-staging, gain increases. No doubt. That is the side effect. But what is the basic purpose? Gain bandwidth product. It should be as high as possible. Second thing, operational amplifier is a direct coupled amplifier. Direct coupled means we are not connecting any capacitor here. And that's why it can amplify AC plus what? DC signal. AC plus DC signal. Output resistance of the operational amplifier is very low. Here we are connecting the, normally we are connecting the common collector configuration. Why the common collector? Because for common collector, the output resistance is very, very low. That is the case. Okay. So that is about the operational amplifier. Now, so this is the basic idea. So already I have covered all the points. I'm just giving you the idea. Operational amplifier is basically a voltage amplifier. Second thing, operational amplifier is a direct coupled amplifier to amplify the DC as well as AC signal. It is basically a differential amplifier, right? These are the points, and it is originally invented to execute mathematical operation. That's why it is called operational amplifier. And which one is the most popularly used IC? Everyone give me the answer in comments box. Pura bhar do comments box mein. Which IC? Which is the famous IC for operational amplifier? Okay. So that is the operational amplifier. Now already I have given the properties. Then next, one by one I will give each and everything the very quick revision within 15 to 20 minutes, and then we will cover questions. First of all, that is the symbol. Positive inverting terminal, non-inverting terminal, supply voltage, that is the 15 volt, minus 15 volt, 10 volt or minus 10 volt. My dear, IC 555 or IC 741 is the operational amplifier, and IC 555 is what? Timer circuit. Okay, that is the right answer, IC 741. Right. Again, 8-pin IC 555 timer is also 8-pin IC, but that is the different thing. It is a symbol of the operational amplifier. Non-inverting terminal, inverting terminal, plus Vset, minus Vset, Vout. If suppose the Vout plus Vset is given as 15 volt, it is given as minus 15 volt, then output will be always less than or equal to 15 volt, or output will be always greater than or equal to what? Minus 15 volt. So what is the range of the output? It will never exceed the supply voltage. It will never exceed the supply voltage. Remember one thing. If the supply voltage is given 15 and minus 15, then that will be the range of the output. Once it is reached up to what? 15 volt, that is, we are saying that operational amplifier enter into saturation. So what is the meaning of the saturation? Why I have given the break for 5 minutes? Break for 5 minutes, that is the reason. अगर ब्रेक नहीं देता ना, थोड़ी देर बाद सब सैचुरेशन में चले जाते और बोलते बस सर अब समझ आ नहीं रहा है, अब आप पढ़ाते रहो, हम चले घर, राइट? तो इसीलिए थोड़ा ब्रेक दे दिया गया. So that is what saturation. So once it is enter into the saturation, it will stop working like an amplifier, right? So that is the problem. Then that is the internal diagram of the operational amplifier. Always remember, there may be the question, this is basically a voltage amplifier. If all practical operational amplifier is given, suppose in a particular numerical, then replace the operational amplifier by its equivalent circuit. Its gain is what? AV into VI. This is, and this is the R0. R0 is the output resistance, Ri is the input resistance, AV is the internal gain. Okay, and normally here we are connecting the RL. Here we are connecting the source. So if suppose a highly practical diagram is given, अभी तक तो question नहीं आया, but it may possible. If the R0 is given, AV is given, Ri is given, then use this formula and use the concept of network. Definitely you are going to get the answer. Okay, don't worry about the question. If everything is given, highly practical operational amplifier is given, then use this diagram. Then this is the actual IC of what? Operational amplifier. 1, 2, 3, 4. These are the terminal 5, 6, 7 and 8. 8-pin IC. Monolithic means on single crystal of silicon. But no one is going to ask you the number and so on. So that is a redundant topic. In other exams, they may ask. Okay, ma'am. Now, condition in the operational amplifier, feedback amplifiers where V negative and V positive is known as virtual short concept. Remember, directly I am giving you one idea. In operational amplifier, we are using what? Virtual short concept. Virtual short concept means when there is a negative feedback. Remember, operational amplifier is divided into two chapters, positive feedback and negative feedback. In case of negative feedback, there is a virtual short concept is valid. Virtual short concept means positive terminal voltage is equal to what? Negative terminal voltage. But condition applied when the AV, open loop gain of the operational amplifier, is given as infinite. If it is given as infinite, means ideal operational amplifier, or the open loop gain or AV is given as what? Very, very high, 10 to the power 6. Then virtual short concept is valid. Virtual short is valid. Otherwise, it is not valid. Or when we are applying the positive feedback, virtual short concept is not valid. You cannot use this virtual short concept in case of positive feedback. Right. So that is the condition. Now, mainly in case of negative feedback, what are the mode of operation? So we are dividing the complete topic and applications of the operational amplifier in two parts. First part is what? Operational amplifier with negative feedback. Second part is operational amplifier with positive feedback. Okay guys, please join the session. क्या हुआ भाई? अब देखो, operational amplifier, this is the inverting mode, non-inverting mode and differential mode. In case of negative feedback, basically we are using in inverting mode. For example, inverting operational amplifier, there is a 180-degree phase shift. Non-inverting mode, that is what? 0-degree phase shift. And third one is what? Differential mode. Differential means at both the terminal, non-inverting as well as inverting, we are giving the signal and output is proportional to difference of the input. That is called differential mode. Which feedback is dominant when both the feedback is present? Yes, Tushar, we will solve one question and you will get the idea about that. Which feedback is dominant? Yes, we will discuss that point. Okay, definitely I will discuss that point with one question. To inverting, because some students are very new and that's why in a sequence we have to cover. Okay, no doubt it is a quick revision. Some student will leave the class, but remember, again with quick revision you are going to get some extra points here. I am not going to waste your time because within 2 hours I have to cover all this topic. So inverting mode, non-inverting mode, differential mode. There are the 3 modes. On inverting mode, we are designing inverting amplifier, inverting summer, right, integrator, differentiator, logarithmic amplifier, anti-logarithmic amplifier we are designing. Or in non-inverting mode, we are designing what? Non-inverting operational amplifier, voltage follower, a number of applications of voltage follower. Okay. Then, and third one, very, very important topic, that is what? Differential mode. Differential mode. Here we are getting the idea about the CMRR, AD and what? AC. And instrumentation amplifier. Then, first diagram is inverting operational amplifier. As you know, what is the gain of the inverting operational amplifier? Very simple, minus RF by RN. R1, normally it is represented as coupling resistor. This is called feedback resistance. If this point is connected here, negative terminal, there is a negative feedback. Here we are giving the V in. This is the inverting operational amplifier. For ideal operational amplifier, the gain is minus RF by R1 with 180-degree phase shift. That's why it is called inverting operational amplifier. It is called inverting operational amplifier. Second important thing, remember the input resistance. They will ask, what is the input resistance seen here? What is the input resistance seen by V in? Always write this answer, R1. What is the input resistance seen by the battery connected here? R1 only, because this terminal voltage is 0, this terminal voltage is 0. So what is the resistance seen up to this point? R in or R1. Virtual short concept, because it is grounded, it is also grounded. This is called virtual ground process, VGP. VGP. Okay then. So that is the case. That is the case. Now, second, when I am considering the practical operational amplifier, always remember exact solution of inverting operational amplifier in case of practical condition. No need to derive the formula, just I am giving you the direct formula. If the AV is given, for example, the open loop gain or AV is given 100 or something else, then use this formula, minus RF by R1 into AV beta upon 1 plus AV beta. where beta is R1 upon R1 plus RF. This is R1. R1 upon R1 plus RF, that is the value of the beta. So what is the standard formula? In number of session I have derived this, right? So new students, you can watch that session, but here minus RF by R1 into AV beta upon 1 plus AV beta. 2 marks question, directly use this formula if AV is given 50 or 100 or 200. It is not infinite. Then exact analysis, you have to use this formula R1 upon R1 plus RF. Then next one, what is the error in the calculation? Approximated value is always greater than the exact value. The approximated value minus exact value upon exact value, you are going to get the error in calculation. Sometimes they will direct ask error. This depends upon the AV beta. If the AV is infinite, error is 0. You can use the virtual short concept. If the AV decreases, error increases. AV decreases, error increases. So directly in what is the error between exact analysis and what approximate analysis, directly you can find, that is the formula. So what is the exact analysis? This is the exact one, that is the approximated one. Take the mod of this and take the percentage change. So percentage change is directly given by 1 upon AV beta into 100%, where beta is R1 upon R1 plus RF. R1 upon R1 plus RF, that is the value of the beta. Okay guys. Okay. Next one. Now, exact solution of inverting operational amplifier. The input resistance is already we have calculated, that is the Rin. Input resistance is what? Rin, that is the Vs by I1. This is nothing but R1. Tell me, what is the feedback mechanism in case of non-inverting operational amplifier? Everyone, what is the non-inverting operational amplifier? What is the gain? Tell me. Right. Now, I am giving you the idea about non-inverting operational amplifier. For non-inverting operational amplifier, what is the gain here? Right. Tell me. So how to check the with the feedback is dominant? Yes, I will give the answer for that question. How to check the feedback. But before that, 1 minute. Give me the answer for this particular question. Okay. This is about the inverting operational amplifier. For non-inverting, the gain is 1 plus RF by R1. But first of all, we will solve this question on inverting operational amplifier. Everyone. First, this is MSQ. The inverting operational amplifier shown in the figure has an open loop gain of 100. The feedback mechanism is voltage series feedback. In case of inverting operational amplifier, remember, the feedback mechanism is what? Tell me, this is right or wrong? First one. AV is equal to V0 by Vs is equal to minus 9. Because the gain is given as 100, you have to use the exact formula for this. Input resistance seen by the Vs is 1.1 kilo ohm. Yes, we have to check. Error in approximation calculation will be 11%. That may be the MSQ 2 marks question. So first of all, remember, this first statement is wrong. Feedback mechanism is what? Voltage series feedback. No, it is a voltage shunt feedback. That's why this is wrong. Second, no doubt, what is the RF by R1? The gain is RF by R1, approximate gain, 10 divided by 1 minus 10. But the gain is not infinite, and that's why the calculated or exact gain will be less than that. It is given less than that. It may be right or it may be wrong. You can find exact value. So how we can find the exact value? Simply, already I have given, find the beta. R1 upon R1 plus RF. R1 1 upon 1 plus 10, that is 1 by 11. First of all, find the beta here. Once you will get the beta, you have to use the exact formula. What is the gain for exact one? Minus AV beta upon 1 plus AV beta into RF by R1. This is the exact one. minus 100 into 1 by 11 upon 1 plus 100 by 11 into 10 by 1 with minus sign. Remember, minus sign. 11 cancel, it will become minus 1000 by what? 111. Minus 1000 by 111, so nearly equal to what? 9. Yes, so that answer is also correct. Third answer, they may ask, input resistance seen by the Vs is 1.1 kilo ohm. Normally we are saying that yes, it is 1 kilo ohm. Ideal condition, this is 0, this is 0, this is called 1 kilo ohm. But the value high is given. If the value high is given, then you have to find the exact input resistance. In that case, input resistance means you have to find this value. Apply the Miller's theorem. Apply the Miller's theorem. Break the RF in two parts. RF upon 1 minus AV. And here we are getting, according to the Miller's theorem, RF AV upon AV minus 1. Break this RF into two parts with the help of Miller's theorem. And remember, if nothing is given about the input resistance, then you can take it what? Infinite. AV is given as, mod of AV is given as 100. But remember one thing, when I am taking the AV, VI, Vn minus Vp. When I am taking the VI, Vn minus Vp, always take AV negative, minus 100. And when we are taking Vi is equal to positive terminal minus negative terminal, always take AV is equal to what? Plus 100. Means in a particular numerical, it is given as what? Mod. It is given as mod. Right? Okay guys? Then try to understand AV is what? If suppose I am taking the Vn minus Vp, you have to check what? Negative. When I am applying the Miller's theorem, because of this Miller theorem, there is these two resistors, one in parallel to the input, one parallel to the output, and then you can calculate the Rin. This is R1. Now, what is the Rin seen by the Vs? It is, remember new students, R1 plus Rf upon 1 minus AV parallel with Ri. If the Ri is given, you have to consider the Ri, but Ri is infinite. Therefore, it will become R1 plus Rf upon 1 minus AV. This is the exact answer. Now, what is the R1? 1 kilo ohm, Rf 10 kilo ohm, AV 1 minus of minus 100. So, 1.1 nearly equal to. 1.1 nearly equal to, and that is the right answer. So, here if you have no idea about that, then definitely in exam hall you are going to make the mistake. Input resistance is 1.1 kilo ohm. This is the minus 9 volt, that is also correct. Error in the approximated calculation will be 11%. Already I have given error. What is the error? 1 upon AV beta into 100%. My dear, what is the AV? 100. What is the beta? 1 by 11 into 100. What is this? 11%. Error and calculation is what? 11%. If it is more than 10%, then definitely we have to use what? Exact solution. We have to use the exact solution. There is a thumb rule. If the error with the approximated answer is coming more than 10%, then we have to go for exact analysis. That is, yes, this is also correct. So what is the answer for this question? BCD. Now, you are going to attempt all the MSQ, yes or no? Yes or no? You are going to attempt all the MSQ multiple select question in exam, or just you are going to leave those questions? Tell me. Tell me, you are going to attempt all the MSQ, because last time 14 questions. Last time in electronics branch 14, 1-4 numerical answer type question, and then what? MCQs. Definitely it may be what? 1/3, 1/3, 1/3. So 65 divided by 1/3 means what? Nearly equal to 20 question we may expect. I am not saying that they will ask 20 question, but 1/3, 1/3, 1/3, then it will become nearly equal to 20 question from MSQ. You have to attempt, because there is no negative marking. Because there is no negative marking, you have to attempt the numerical answer type question as well as what? MSQ. If suppose I am getting the B or C, okay, mark it. But if you are giving the partial answer, 0 marks. No negative marking, but you are going to get the 0 marks. If you are going the full answer B, C, D, then you are going to get the 2 marks. This is the question. Yes. कई लोग होंगे उनको पता ही नहीं है MSQ अटेम्प्ट करना है या नहीं करना है. Right. Now the next question is what? Next is voltage follower. Question on voltage follower. With this I am going to give you the idea about what? All the idea about inverting, non-inverting operational amplifier. So negative marking in only MCQ, no? Yes, in MCQ only. In MSQ there is no negative marking, and NAT there is no negative marking. Which of the following are correct statement about the voltage follower? Which are correct? New students, please try to give me the answer again. Which of the following are correct? Means again MSQ. MSQ. So tell me which are correct. Right. Remember, for non-inverting operation, it is a special case of non-inverting operational amplifier. To get the idea about the non-inverting operational amplifier, quickly, non-inverting operational amplifier, this is RF, this is R1, this is ground, minus, plus. Here we are connecting the VS. What is the formula? Exact gain is given by 1 plus RF by R1. Approximate given gain is given by AV upon 1 plus beta AV. Again the beta is equal to R1 upon R1 plus RF. Input resistance, if it is asked after the feedback, is given by input resistance of the open loop operational amplifier into beta AV. Remember that. Input resistance increases because the feedback mechanism is voltage series feedback. What about the output resistance? Output resistance is 1 plus beta AV. It is divided because in this feedback mechanism output resistance decreases. Feedback mechanism is voltage series. Voltage series feedback. Now it is a non-inverting voltage follower is a special case of this. When we are making the RF nearly equal to 0, then it is converted into what? Voltage follower. So voltage follower is nothing but we are giving the negative feedback here. RF will become 0, minus, plus, and that is the VS. It is a special case of non-inverting operational amplifier. And that's why what is the gain here? Closed loop gain will nearly become 1, nearly equal to 1. Second thing, phase shift is 0 degree. Feedback mechanism is voltage series feedback, and it is used in designing of what? Butterworth filter. It is used in designing of what? Sample and hold circuit. Sample and hold circuit. We are connecting the voltage follower. It is used in designing of sample and hold circuit, right? Feedback factor beta is nearly equal to 1. Yes, we can say why it is wrong. Why it is wrong? Nearly equal to 1, that is not exactly equal to 1. What is the value of R1 and RF? Practically it is not 0 and not R1 is not infinite, right? Practically we are saying that beta is exactly equal to 1. But remember one thing, when we are saying that beta is nearly equal to 1. Feedback mechanism is voltage series feedback. Closed loop gain is exactly equal to 1. No, who said? It is slightly less than 1. Slightly less than 1. Tushar, are you getting my point? Slightly less than 1, right? Where it is written, which of the following are correct statement about the ideal voltage follower? It is simple written voltage follower. So in a voltage follower, actually what we are doing, we are just making this RF and R1 ratio very less than 1, not making 0. RF by R1 ratio very less than 1. When I am making the RF by R1 ratio very 1 means RF is very less than R1. So RF is negligible, R1 cancel. It is nearly equal to what? 1, or otherwise it is less than equal to 1. Is it clear? This point is clear, my dear students? Okay, this is the point. So this point MSQ means what? A, B and C exactly equal, not exactly equal to 1, that is slightly less than 1, because what is the exact formula? AV upon 1 plus beta AV. So we are saying that this is nearly equal to beta AV is very greater than 1. So we are neglecting the 1. Then AV cancel 1 by beta. 1 beta is what? Equal to 1. That's why we are getting the 1. So we are choosing approximation. We are doing the approximation here. Okay. Then this is a very important question on inverting operational amplifier. Every year, every 1 year or 2 year or 3 year, after 3 years, there may be the question. What is the answer for this question? Assuming the operational amplifier to be ideal. Here the ideal operational amplifier is given. It is nothing but a inverting operational amplifier, but 1 kilo ohm, 10 kilo ohm, 10 kilo ohm, 1 kilo ohm resistor is applied here. This is a standard circuit. Sometimes Z parameter is given for this diagram, or sometimes direct diagram is given here. T network. This is the T network. Tell me, what is the, which answers are correct? This is again MSQ. Assuming the operational amplifier to be ideal, which are correct? V out by V in, input resistance, feedback mechanism, and V out by V in is equal to. So out of A or D, one is correct. What is the input resistance seen by? What about this? You have to check. And feedback mechanism, it is an inverting operational amplifier. That's why it is correct. That's why it is correct. Feedback mechanism is voltage shunt feedback. Already we have discussed. So Chinmay Roy given the ABC answer. Okay. Now, my dear friend, try to understand this concept. It is actually it is a standard circuit. I think right. This one. Try to understand. This voltage is 0. This voltage is 0. Virtual short concept. So what is the input resistance seen by this? Always remember the input resistance we have to calculate the battery value of the battery divided by current given by the battery. What is the current given by the battery? Definitely there will be the current. What is the current? V in minus 0 by R1. This is the 1 kilo ohm. What is the current given? V in minus 0 by R1. So what is the current? V in by R1. Put the current here. So V in cancel. What is the answer? R1. That is the 1 kilo ohm. 1 kilo ohm is the answer, and that's why this is wrong. You are giving the AB answer, Chinmay Tushar. B is wrong answer in this case. B is wrong. Okay. So assuming the operational amplifier to be ideal, V out by V in minus 120 input resistance seen by V in, feedback mechanism is voltage shunt. This is correct, but that is wrong. Now what about the out of A or D? 1 is correct. Out of A or D, 1 is correct. Then what is the gain? To find the gain, you have to apply the KCL here, but otherwise it is a standard circuit. But I am giving you the very simple method. Right. Now, write down the KCL at this point. This is 0, 0 minus V in by 1 plus 0 minus Vx. You can choose the voltage Vx by what? 10 is equal to 0. From this you will get the Vx is equal to minus 10 V in. First equation. I am writing the KCL at this point. Remember, the current enter into the operational amplifier is 0. So 0 minus V in by R1, 0 minus Vx upon 10, you will get the Vx in terms of V in. So now write down the KCL at Vx. So it will become Vx minus 0 by 10 plus Vx minus 0 by 1, Vx minus 0 by 1 plus Vx minus V out by what? 10 is equal to 0. You can take 10 as a LCM. It will become Vx plus 10 Vx plus Vx minus V out divided by 10 is equal to 0. So what is the V out is equal to? 10 will become 0. It will become minus 12 times of Vx. And what is the Vx? What is the Vx? Remember 1, 1, 1, 1, 1, 1. Yes, this is the minus sign. So it will become plus here. This is the minus sign. That's why it will become plus here. Now put the value here. It will become minus 120 times of V in. What is the V out by V in? Minus 120. That is the gain of this system. So which two are correct? A and C only. Oh no. रुक जाइए इसको कुछ हो गया गड़बड़. एरर है. Give me 1 minute. Okay, right? So that is about this circuit. Remember, this was the question. Okay, sorry, there is some technical issue. Okay, now, so what is the use of that circuit? नहीं, screen चलेगा, कोई नहीं. ये technical error है, or no, there is some problem with that. Bleed blue, that is correct. Okay, try to understand. In a previous diagram, I think now it is fine. Wow. Yes, in a previous diagram, this is a standard diagram. Please remember the answer for this particular question and what solve like this, right? Apply the KCL in any type of question. You can apply the KCL, or second thing, you have to apply what? Virtual short concept if ideal operational amplifier it is given. Ideal operational amplifier if it is given. Okay, then next one, most important one is what? Differential amplifier. Differential amplifier means we are giving the two inputs and we are getting the output, and then output should be proportional to what? Difference of the signal, but practically we are getting the AC VC. Here VD is nothing but V1 minus V2, difference of the signal, or AC is common mode gain. Common mode gain. No need to write all these things, and this is what AD. AD is called difference gain, and what is the VC? Common mode signal. Common means average value. Average value. Always remember, this is the unwanted term, and this is what? Wanted term, and that's why ideally AC should be equal to what? 0, or practically it should be as low as possible. And here it is one figure of merit, that is called common mode rejection ratio, that is called mod of AD by mod of AC. That is called common mode rejection ratio. When we are calculating in dB, you have to calculate 20 log of that value. Then you can find the value in what? dB. This is the common mode, this is the symbol for that, and that is the dB. 20 log base to 10, then it is converted into what? dB. This is the error. Sometimes they will ask what is the percentage error. You have to find the percentage error from this formula. This is unwanted term, this is the wanted term, and that is the practical differential amplifier. Now, try to solve some question on that. Right. Please everyone try to give me the answer for this question. Very basic question, very basic question. 20 log of, yes, 20 log means what? Log means log base to 10. Now, if the differential voltage gain and the common mode voltage gain of the differential amplifier are 48 dB and 2 dB respectively, then its common mode rejection ratio is. What is the common mode rejection ratio? Everyone tell me. Very basic question on what? Common mode gain, common mode voltage gain. So this is given 48 and this is given what? 2, right? Then what is the answer? What is the answer? A, B, C or D? This is the MCQ. So this time very simple question in exam they will give you what? Very simple question, but it is a logical question, right? So some student will do 48 divided by 2, because AD by AC you will get the 24. But 24 is given A and you are putting the A, but it is wrong answer. It is wrong answer. In dB, always remember CMRR in dB is given by 20 log of AD by AC. Then it will become 20 log of AD upon plus minus 20 log of AC. 1 minute, AC. So 20 log of AD minus 20 log of AC means what? What is the answer? Kirthana? No, that is the wrong answer, right? So in a dB you have to subtract. So what is the answer here? You have to subtract means 48 minus 2. So in a dB division is converted into what? Subtraction. So 48 minus 2 it will become what? 46. 48 minus 2 it will become what? 46 dB. Is there any doubt? No doubt. Okay then. Next question. Next one. C is the answer. Then Very basic question on differential amplifier. Just with this question, all the formula we will discuss here. Again, that is the differential amplifier by using ideal op-amp. This is the ideal op-amp. Here, there is a negative feedback. We are connecting the one voltage in the positive terminal as well as negative terminal. You have to find out what is the output voltage in that case. Remember, this is a very standard formula, right? What are the standard answer for this question? Give me the answer. What is the answer? Yes, everyone try to give me the answer. What is the answer for this particular question? Right. Remember, this is a standard circuit, all the formula in one screen. Then new students try to give me the answer for this particular question. Okay, sorry for write down the rest formula. 1 minute. Give me only one. I am taking 1 minute break. इसका solution निकालते हैं थोड़ा. There is some problem. Okay, what is the answer? Answer is what for this particular diagram you have to calculate. Right, then सॉरी सम टेक्निकल इशू, थोड़ा वेट करते हैं. फिर हम लोग इसको सॉर्ट आउट करके फिर आप लोग जाइएगा नहीं, 5 मिनट्स में इस प्रॉब्लम को सॉर्ट आउट करते हैं. ओके गाइस, प्लीज डोंट लीव द क्लास. I will be back just after 5 minutes. Right guys? Give me only 5 minutes. Is it okay? Now is it okay? Okay then. Now this is the differential amplifier. Now quickly we will revise this. What is the differential amplifier? Right. First of all, always remember, if RF by R1 is equal to what? RG by R2. If it is given RG by R2, if it is given, then my dear friends, directly remember AC is equal to 0, CMRR is equal to what? Infinite, and the output will become ADVD only. What is the AD here? Always remember RF by R1, that is the ratio, and VD is non-inverting minus inverting terminal voltage, V2 minus V1. Then you will get the proper polarity. Okay, proper polarity. I think that quality is fine, no issue. Right. 1 minute. Okay then. So that is the case, first case. Then next one. Okay. This is the case. If this condition is not satisfied, directly you have to write the output is equal to 1 plus RF by R1 into what voltage at this point, that is given by RG upon R2 plus RG, into what? Non-inverting terminal voltage, that is V2, minus RF by R1 into what? Inverting terminal voltage. So that is the case, V out. So number of times that ratio is not equal, RF by R1 is not equal to what? RG by R2. So then you have to write this, otherwise you have to write this formula. So in a previous question, in that particular question, that ratio is not same. Yes, if the ratio is not same, then directly you have to apply the voltage. So directly, new students, directly write this formula. V out is equal to 1 plus RF by R1 fast into voltage at this point 8 divided by 1 plus 8 into non-inverting terminal voltage, that is the 3 volt, minus 5 RF by R1, 1 RF by R1 into 2. This is finished. This is the 6 into 8 into 3 divided by 9 minus 10. This is the 3 and that is 2. 16 minus 10. So what is the answer? 6 volt. Very simple question. 6 volt. So this is the case. Okay then. So that is the answer. Now next one. This is about the differential amplifier. That is the error. If suppose we want to calculate the error, then a differential amplifier has input voltage 1050 microvolt, V2 950 microvolt, CMRR 1000. What is the error in the differential output? If suppose error is asked, it is given in the percentage. Always remember, V0 is equal to ADVD. This is the wanted. And what is the unwanted? ACVC. So what is the error in percentage? that is given by AC VC upon what? Unwanted upon wanted into 100%. Finished. This AD by AC is called CMRR, then that's why it will become CMRR. More will be the CMRR, less will be the error. And VC upon VD. What is the VC? Common mode signal. VD is the difference signal. Common mode means you have to calculate the average. V1 plus V2 by 2. So V1 is 1050 plus V2 950. What is the average or common? Divided by 2. You will get 1000 microvolt. 1000 microvolt, that is the common. And what is the VD? Difference signal. 1050 minus 950, and that will give you the 100. Use this 1 by 1000. VC is 1000 upon VD. What is the VD? 100 into 100%. If you want the percentage, then multiply it with the 100. 1000, 100 cancel. What is the answer, my dear students? 1% is the answer. There will be 1% error, CMRR, right? If you want the error less than that, then definitely you have to increase the value of what? CMRR. So that is the formula. This is very, very important one. This is a very, very important one. This is the formula, and that is the formula for error. Okay. Then this is about the CMRR. Now, one minute. This circuit. Everyone tell me, what is the name of this circuit? It is written here. And that is the use of what? Voltage follower. Right? They will give you the 1 mark question on that. This is the voltage follower, and R and C is connected here. And remember, if the C is connected here, R is connected here, always you can compare with what? Standard diagram, passive filter. In a passive filter, if the C is connected here, R is connected here, so we are taking the output, we are giving the input, and this is a high pass filter. High pass filter. And what is the cutoff frequency for this high pass filter? In omega naught, that is the 2 pi f naught, that is called cutoff frequency, 1 by RC. 1 by RC. So they will ask you the name as well as what is the cutoff frequency of this filter. So this is the high pass filter. And what is the cutoff frequency? 1 by RC. Or if it is asked in hertz, then divided by what? 2 pi. Divide it by what? 2 pi. Okay, guys. So that is the answer. Next. Next one. Lagging means what? Sound or picture quality? That is the problem. Yes, tell me. I think now everything is fine, no? Okay. Now, this is the case. Second one, this is about the high pass. Similarly, when we are changing the position of C and R, it will become what? Low pass filter. Low pass filter. Then, always remember, when high pass filter is followed by the low pass filter, it is called what? Band pass filter. Low pass filter is followed by the high pass filter followed by the low pass filter. It is a band pass filter. Band pass filter. Now, time to solve some numericals on this. So everyone give me the answer for this questions. That is the questions. Okay. If the C is grounded, means what? What is the grounded program? Yes, if the C, in place of R we are connecting the C, or in place of C we are connecting R, then it is a low pass. What is the name of this circuit? Assume that the op-amp of the figure is ideal. If Vi is a triangular wave, then V0 will be. First of all, remember that in operational amplifier it is a standard circuit. If here we are connecting the R, here we are connecting the C, then it is what? Differentiator. This is actually a differentiator. Or when we are connecting the C here, R here, it is what? Integrator. So if the differentiator, so when we are giving the triangular wave, it will differentiate it, we are going to get what? Square wave. So sometimes this type of easy question you may expect. This is a square wave. Directly we can find that is a square wave. Then again they may ask, but what is the new? They may ask what is the cutoff frequency for this? Tell me, what is the cutoff frequency, everyone? What will be the cutoff frequency for this diagram? No doubt it is a high pass filter, integrator, sorry, differentiator. Definitely it will have what? Some cutoff frequency. So what is that cutoff frequency? Is there is any cutoff frequency for this diagram? There is no cutoff frequency, and that is called what? Role of problem. This is the role of problem. It comes in a feedback. Suppose here R is connected, C is connected, that is called what? Differentiator. When here C is connected, R is connected, then it is called integrator. So what is the cutoff frequency? Cutoff frequency for this is 0. Watch this diagram. Nothing. We can't find the cutoff frequency. Continuously the gain will increase. No cutoff frequency. To introduce the cutoff frequency, we are connecting R1 in series with this R1. So they will ask why we are connecting the R1 in this series with the C. When they will ask what is the purpose of the R1, remember it will introduce a cutoff frequency, means it will introduce a pole here. So what is the pole here? Then it will become 1 minute. Then it will become okay. What will be the curve? This type of curve. Once the pole is introduced, that is the curve. And then what is the cutoff frequency? They will ask this question. Then in that case, the cutoff frequency will become 1 by R1C. R1C. So if the R1 is not connected, that will be the diagram, a straight line. If the R1 is not connected, that will be the diagram. But if where R1 is introducing, it will introduce a pole, and because of that pole, this is the 20 dB per decade, and that is what 0 dB per decade. So that will be the question. Okay. So yeah, any doubt in this question? Any doubt? That is a very important question on what? This circuit. Right. Now next one. No doubt they will ask what is the value. You are having the idea what is this differentiator, but next level of question is what is the purpose of R1 here. Then okay, my dear friends, if I am talking about this circuit, a very standard circuit, but we can make MSQ on this diagram, MSQ. But tell me, first of all, tell me what is the answer for this question. Then I will create a MSQ on this diagram. This is a standard circuit. It is a standard circuit. If R2 is not connected here, again it is an integrator. If R2 is connected here, it is converted into a band pass filter. So what is the band pass filter? An active filter is shown in the adjoining, no sorry, it is a low pass filter, not band pass filter. I am saying that low pass filter. No doubt it is an integrator, but once I am connecting what register here, R2. Because of that R2, it is converted into what? Low pass filter. An active filter is shown in the adjoining figure. The DC gain and the 3 dB cutoff frequency of the filter respectively are nearly. So DC gain you have to find and cutoff frequency. DC gain means what? DC gain means what? Capacitor will act as open circuit. Under DC condition, capacitor will act as open circuit. So what will be the gain? That is given in what? dB. So in a gain, the dB, it will become 20 log of RF by R1. 20 log of RF by R1. So what is the RF here? RF means R2. What is the R2? 159 and 15.9. 159 divided by 15.9, that is log 10. 20 log base to 10 of 10 is what? 1. You are going to get the answer 20 dB. DC means, always remember, the capacitor will act as open circuit exactly at 0 frequency, that is F is equal to 0, and that's why this diagram is simply converted into inverting operational amplifier RF R1, and that gain is connected here, and that's why the maximum gain at that point will become minus RF by R1. But when we are calculating in dB, we are neglecting the sign. We are simply calculating dB, means magnitude of that. Okay. Then what is the 3 dB cutoff frequency? When we are connecting the C1 here, C1 parallel with R2, then the cutoff frequency will become omega naught is equal to 2 pi f naught is equal to what is connected in feedback path, R2 into C. This is, if it is R1, so R1 into R2. This is R2 into C1. R2 into C1. So always remember this is the feedback path. So what is the R2? Put the value 159. What is the C1? 1 nanofarad. And then you can find the, and divide it by what? 2 pi, and you will get the answer. So always remember F0 will become 1 by 2 pi R2 C1. Now that is a normal question. That is a normal question or a standard question. But they may ask, if suppose I am removing the R2, what will happen? Remember, with R2, that is the curve. Up to this point it is constant, and then that is the curve. Here we are going to get a bandwidth, and this is called cutoff frequency because of what? R2. This is called cutoff frequency. Already we have calculated this. Now, or what is the maximum gain? RF by R1 into a dB 20 log of RF by R1. But if R2 is not there, if the R2 is not there, then what about the curve? We are going to get this type of curve. This type of curve. Continuously the gain will decrease, and there is called roll of problem. Roll of problem. What about the bandwidth? 0. Bandwidth means the band of frequency for which the gain is almost constant. So here we are having the bandwidth with R2. With R2. Without R2, that is the curve. So they will ask, what is the purpose of the R2? Simply roll of problem, it will remove the roll of problem and it will limit the maximum gain. Because of that R2, that is R2 by R1. RF is nothing but R2 by R1, that is the maximum gain. If suppose R2 is open circuit, then it will become infinite. If we are removing the R2, then maximum gain will become what? Infinite. So circuit will become unstable. Circuit will become unstable. So that is the purpose. So they will ask this type of questions. Remember that. Third use of this diagram is, then if that is given, for example, this diagram is given. What is the name of this diagram? This is C. This is diagram. This is R1, like this is the C. And this is the Vn. Okay. This is called Vi of the operational amplifier. This is the Vn and that is the Vp. If the gain of the operational amplifier is given as 1000, they will ask, what is the time constant of the circuit? Everyone tell me, what is the time constant of the circuit? Tell me. What is the time constant of this circuit? If it is given as 1 microfarad or if it is given as 1 kilo ohm, then tell me what is the time constant of this circuit? Time constant of this circuit. Right. Time constant, we can't find the time constant, right? In this case. Okay. RC. You are saying that RC. Okay. Hemant. But that is the wrong answer. Na? That is the wrong answer. So first of all, to calculate the time constant, we have to apply the Miller's theorem here. So what is the Miller's theorem here? Right. This is the Miller's theorem. First of all, break the capacitor. This is the R and apply the Miller's theorem. With the help of Miller theorem, one capacitor will be here. This is called C1. And one capacitor will be here, C2. You know the Miller's theorem? I am giving you the formula. Then what is the value of the C1? C1 will become CF. This is called feedback capacitor CF into what? 1 minus AV. Right? That is the CF into 1 minus AV. So what will be the AV? AV is 1000. But when I am taking the Vi is equal to what? Vn minus Vp. Always remember. Then you have to choose the negative value. Negative value of AV. When I am putting the negative value, the C1 will become 1000 times of 1 into CF. 1001 times of CF. So microfarad capacitor is converted into what? Millifarad capacitor. Microfarad capacitor is converted into what? Millifarad capacitor. So what is the new time constant? It is given by R1 C1. And here you have to use this R1, 1 kilo ohm. And in place of Cn, you have to use 1 minus AV. That is nothing but 1000 times of CF. Remember, this is a very important concept here. Okay. So that is the value. So in case of, no doubt it is an integrator. But if they will give the practical operational amplifier, so you have to find the capacitor. And this is called what? Capacitor multiplier. It will increase the value of the capacitor. Here the value of the capacitor is only 1 microfarad. Here it will increases up to what? 1001 times more than that. That's why it is called capacitor multiplier. Okay, that is important concept. Second thing, similarly in integrator, this is about the integrator. So what about the differentiator? In case of differentiator, if they ask what is the time constant of the circuit, this is the differentiator, the standard circuit of differentiator. We are changing the position of resistor and capacitor. If they will ask what is the value of the time constant, always remember, break this by using the Miller's theorem. Then according to Miller's theorem, this will become C, this will become R1, and this is the C1, this is the V in, this is negative, this is positive. And now my dear friends, what is the value of the R1? According to Miller's theorem, it will become RF upon 1 minus AV. If AV is 1000, you have to choose the negative value of this, then it will become RF upon 1001. So it is called resistor divider. It will decrease the value of the resistor, it will decrease the time constant. It will decrease the time constant. What is the time constant of this circuit? R1 C1. It will become RF C1 divided by 1001. And that is called effect of what? Miller's theorem. Miller's effect. Miller's effect. It acts as what? Resistance divider circuit. And the previous one acts as capacitor multiplier circuit. This is the capacitor multiplier circuit. Okay, that is important one. That is very important concept here. Any doubt my dear students? Any doubt here? यार सब चले गए. अब बताइए. थोड़ा सा बफरिंग भी हो गया. सॉरी टेक्निकल इशू. फॉर टेक्निकल इशू के लिए तो सब कोई अभी भी इंपॉर्टेंट टॉपिक्स होने वाला है. नाउ नेक्स्ट वन. नेक्स्ट, I think these 2 points are clear, because of that meaning topic is what? Easy topic, but this is very important one. Now another one, that is another very important topic, is what? Voltage to current converter. One student asked me, sir, if both the feedback is given, then how we can judge? How we can judge which is dominant, right? So if both the feedback is given, then always calculate the Vp and Vn. If the Vp is greater than Vn, positive feedback is greater, or Vn is greater than Vp, negative feedback will be greater. But what about the feedback, right? So what about the feedback? So in this diagram, both the feedbacks are present, negative as well as what? Positive. So some number of times they will give you the numerical like this. So if suppose the negative feedback is dominant, then we can use the virtual short concept. But if the positive feedback is dominant, we can't use the virtual short concept. So what is the method here? So what is the method here? In that case, first of all, if it is a new question, then always check. Make all the input battery 0. All the input sources 0. Suppose in a particular numerical, if the voltage source is given, make it what? 0 by what? Short circuit. If the current source is given, make it 0 by what? Open circuit. Open it. Simply open it. Remove the source. But consider the internal resistance. Always consider its internal resistance. For example, in this case, I am removing the source. I am making it what? 0. Try to understand this concept. This is 0. Now I am making it 0. Already it is 0. I am making it 0. Now find the Vn in terms of V0. So according to voltage divide rule, Vn will become R1 upon R1 plus Rf into what? V0. R1 upon R1 plus RF into V0. Like simple voltage divide rule, what is the current enter into the operational amplifier? 0. When I want to calculate the VP, now from VP this is connected to ground, from VP this is connected to ground. That's why R2 and RL are in parallel. R2 and RL are in parallel, and that's why you can find the VP is equal to R2 parallel with the RL upon R2 parallel with the RL plus what? RP. Plus what? RP into what? V0. Simply voltage. Find the VN, find the VP, make all the input signal 0. So VP will become this much, VN will become this much, and that is the answer. Tell me, by watching this, if the VN is greater than VP, what will happen? If the VN is greater than VP, means negative feedback is more. If the VP is greater than VN, positive feedback is more. If the negative feedback is more, you can use the virtual short concept. This voltage and this voltage is equal. This voltage is this equal is equal. I think that concept is clear, everyone. So in any diagram, make the input what? 0. Make the input is equal to what? 0. For example, one time one question was given here. Try to understand this question. Right. This is minus, this is plus. One current source is given here, and output is asked here. Okay, no problem. This is given as RF. One current source is given as 1 milliampere. RF is given as 10 kilo ohm, and that is what? Ground. Or here, one feedback is connected here. This is R1, this is R2. R1 is given as like 10, R2 is given as 1. Okay, no issue. 10 or 1, that is the positive feedback. This is the negative feedback. Okay. Which feedback is dominant then? Which feedback is dominant? If you want to solve this question, you have to use the virtual short concept. You will find the voltage in terms of VP, and then you will equate the VP is equal to VN. But before that, you have to prove that which feedback is dominant. To find the feedback, first of all, make the current source open circuit. This is the input current. Make the current source open circuit. When I am making the open circuit, this is the RF. This is the negative, this is the positive, and this is the V0. Now, what is the value of Vn? Because there is no current inside the operational amplifier, input resistance is infinite, so Vn will become V0. Vn will become V0. And then what is the value of Vp? This is R1, this is R2. My dear friends, it will become Vp. Vp will become R2 upon R1 plus R2 into V0. What is the R2? 10. What is the R1? 1. So 10 by 11 into V0. Here Vp is less than Vn because Vn is V0. It is 10 by 11 V0. Vn is greater than what? Vp. Tell me which feedback is dominant. Which feedback is dominant in this diagram? It is visible to you. Simply make the current source is equal to 0. Open circuit. Find the Vp and Vn in terms of V0 only. If the Vn is greater than V0, we can say yes, negative feedback is dominant. Then solve this question by using the virtual short concept. Now you have already calculated the Vp. What is the Vp? 10 by 11 times of V0. Put here 10 by 11 times of V0. Equate it to what? Vn. Equate it to Vn and write down the KCL at this point. You will get the output. Very simple question. Very simple question then. I am going to solve this. Once it is satisfied that negative feedback is more, then directly use same calculation here. We can use the same calculation here, but this time we have to make Vp is equal to what? Vn. Vn is equal to Vp is equal to what? 10 by 11 times of V0. Write down the KCL at this point. What is the current? Incoming current 1 milliampere is equal to what is the outgoing current? Vn minus V0 by incoming is equal to outgoing. Vn minus V0 by 10. Right, this will become 10. What is the Vn? 10 by 11 into V0 minus V0. Now it will become 110 is equal to 10 V0 minus 11 V0. So it is minus V0 is equal to 110. So what is the V0 is equal to minus 110. Answer. minus 110 voltage. That is the answer. This point is clear, my dear students? This is clear, easy. So in this way we can judge whether which feedback is dominant. So already we have calculated the VP. To use that same data, but this time VP is equal to VN. VP is equal to VN. Check my calculation also. Okay. So in every diagram, first of all check which feedback is dominant. Agar if you have any doubt, otherwise this is a standard diagram. If in this standard diagram, if this condition is satisfied, always check this condition. RF by R1 is equal to RP by R2. Always remember, RF by R1 is equal to RP by R2. No need to check. If this is satisfied, RF by R1 is equal to RP by RT, 100% negative feedback is dominant. Because already in the derivation we have proved, but we have limited time, so negative feedback is dominant. If this ratio is satisfied. Normally they will satisfy the ratio RF by R1, that is called balance bridge condition, RFP by R2. Once it is satisfied, if the input is connected to inverting terminal, then the output current will become minus Vs by R2, minus Vs by this one, R2. This resistor always. This is the value of the I naught. It is independent of RL, and that's why it is called voltage to current converter. But if this Vs is connected to non-inverting terminal, for example, in this diagram, it is connected to non-inverting terminal, and that ratio is satisfied. RF by R1 is equal to RP by R2. For this question, it will become positive value of Vs by R2. Positive value of Vs by R2. That is the value. Okay, guys. That is the answer. Now, so ready to solve this type of questions? Yes, it is a voltage to current converter, current to voltage converter. Sometimes we are having the current sources and so on. Directly standard answer, right. Now, we will solve with the inverting operational amplifier. We will, I will try to get one extra class for what? Operational amplifier with positive feedback. Okay, we will cover. So we will arrange and then I will inform you. Okay. Sir, I am a third year CSE student. 75% gate syllabus. So sir, should I complete the next 25 syllabus? Now just, yeah, we have limited time. If you already completed the 75%, then please revise it. Right? Revise it. Right, if suppose you are going to cover what remaining 75% question, 25%, then what about the remaining 75? It will hamper your preparation. Okay, please solve the previous year question and so on. Or there is another approach. You can just go through the easy portion of that remaining 25%. It's easy. Just 2 plus 2 is equal to 4. 2 plus 2 is equal to 4. Yes. Right, you are saying that, sir, if the positive feedback is dominant, then yes, output will be plus Vset or minus Vset. It may be both. It may be. We have to satisfy the condition. It may be plus Vset or what, minus Vset, but we have to check the condition whether it is plus Vset or minus Vset or both. It may be. Now, try to understand. This is a logarithmic amplifier. If the diode is connected here, R is connected here, Vn is here, then it is called logarithmic amplifier. This is the logarithmic amplifier. Okay, guys. Now, Chinmay, we need full and complete revision, sir. Yes, you need full and complete revision. Yes, so that's why I have class just after this, right? And that's why I will arrange one extra session. I will ask them to arrange one extra session. That is what, on operational amplifier with positive feedback. That is what, multi vibrators, bistable, monostable, astable, important numericals on that, important topics on that, and then oscillators. Win bridge oscillators, Colpite-Hartley oscillators. We will cover that. Today I will cover the operational amplifier with inverting, operational amplifier with negative feedback only. Now that is the diode. It is a logarithmic amplifier. Remember. But what will be the question? No doubt. It is a standard circuit. This is a logarithmic amplifier. Output is proportional to log of the input. But they will ask, what is the maximum value of the V0? So always remember, when the diode is in full conduction, what is the maximum voltage across the diode? 0.7 volt. And virtual short concept, this is 0, this is 0. When we are calculating the V0, 0 minus V0 is equal to 0.7. And that's why, what is the maximum value? Minus 0.7 volt. minus 0.7 volt when the diode is in conduction. When the diode is in what? Conduction, right? Okay, Ravi Shankar sir, if I am revising one concept then I am forgetting another subject. It is hard to digest. My dear, that is not the problem with you. This is the problem with what? Majority of the students. Don't worry about that. Okay, and that is a normal tendency, right? In exam hall, please revise the concept, solve the question, right? Don't worry about the result. Simply in exam hall, it will work. So go for 10 minutes more meditation daily. Definitely it will help. Don't worry about that. Common problem with all the students. Okay, that is the answer. Yes, 0.7. Remember this. This is the logarithmic amplifier. If suppose it is asked, if it is a current, then what is the V0? Always remember this voltage is 0, this voltage is V0. So what is the voltage across the diode? 0 minus V0 is equal to what? Minus V0. This is the current through the diode. This is called feedback current, and the same current will pass through the diode because the current enter into the operational amplifier is 0. So ID will become IS. ID will become IS. And what is the ID? ID is given by reverse saturation current e raised to power Vd by eta Vt minus 1 is equal to Is. So what is the Vd? Vd is minus V0. Okay. E raised to power minus V0 upon eta Vt minus 1, that is equal to what? Is, source current. Then when I am solving this, it will become minus V0 upon eta Vt. This is equal to Is upon I0 plus 1. And now you can take log, and that's why it will become V0 is equal to minus eta Vt log of Is plus I0. Approximately, because the reverse saturation current is very, very small, Is is very large, so normally we can neglect the 1. It is Is upon I0. So output is proportional to log of the input, and that's why it is called logarithmic amplifier. That will be the question on logarithmic amplifier. Then simply they will ask what? Okay, problem hai. One minute. Okay. Then they will ask you if I am connecting the transistor, then what will be the result. Okay. तो आज के लिए इतना ही. ये थोड़ी सी फिर से प्रॉब्लम आ रही है, फिर नेक्स्ट क्लास में हम लोग इसको पूरा करेंगे. सॉरी फॉर इंटरप्शन. अभी देखो पूरी स्लाइड्स आई हैव टू अपलोड द पीडीएफ. अगर इसने ऐसा ही किया तो सब कुछ गायब हो जाएगा यहाँ. यस, I will arrange one session because analog is very lengthy subject, na? Analog is what? Very, very lengthy. Now, tell me, you can ask any question. Now, next for 3 minutes, you can ask any question related to that exam. Okay. What about the students? How many students from electrical branch, electronics branch and instrumentation branch? Remember one thing, electrical students, analog will play a crucial role in your selection. You have to solve each and every question from analog circuit. You are going to get easy questions from analog, but sometimes it is a conceptual, but it is a standard question. If you are solving the previous year question, yes, you will be able to solve the question. Don't worry about that, but try to solve last 15 years, minimum 15 years question. Okay. Of electronics students, sometimes we may get what new questions, but always remember 70% question on the old concept. So if the 70% question on the old concept, so don't worry about that. Or in analog, if suppose you are finding the level is very, very high, please leave that question. If it is a MSQ, then attempt. If it is a numerical answer type, then attempt. If it is what? MCQ type, or you are not confirm about the result, please leave it. Sometimes they are giving what very new type of concept and so on. So simply leave it. Otherwise, you are going to waste your time. It is a core subject. It is a conceptual subject. In electrical as well as in electronics. In instrumentation, sometimes we are getting the question level of that particular question will be maybe very, very high. Right, so please leave it. Don't worry about that. Okay. So if it's because there is a negative marking, अगर negative marking नहीं है तो attempt कीजिए. Okay then. तो ये है. और आपको देखो मैं अगली क्लास जो अरेंज करूंगा, I will arrange for symmetric trigger and other waveform generator, oscillators. We will cover all the topics So don't worry about that. Then till then, please revise all this. So Rakesh Talreja sir will take one session, General Aptitude GATE 2023, 15 marks in just 15 hours. Please subscribe our channel so that you will get the notification about this session. This is a very, very important session by Rakesh Talreja sir. Please subscribe our channel. Second thing, 1 minute. This is a GATE and ESE test series. Get unlimited access to full length mock subject test. That link is given in description box. This is time to join what test series. Okay. Some students are making the silly mistakes. Why you are making the silly mistakes? Some students want to prepare what new topics, but it is not the time to start what new topics, right? So what about your command on the prepared topic? To simply go through the mock test till what 20th January, right? After 20th January, no need to give the mock test. Then you will get the idea. Please revise the subject accordingly. Okay, you will get the idea about the topics. And that is the link is given in the description box. Full length mock subject tests are available here. Right. And what about the, okay then, this is all about my session. Okay then. So tomorrow morning 10 to 2 p.m. control, and then 4 to 8 p.m. again analog, part 2, and that is the control part 2. Okay then, thank you for attending the session. Thank you very much. You are on BYJU'S exam prep. Subscribe the channel, like the session and share the link of this session. Thank you and good night.